good morning, good afternoon, good evening, wherever you are. Welcome to the 2022 GREEN4SEA Forum. This year, the issue of the environmental challenges is more topical than ever. We have several hot topics on the agenda, with the key one being the decarbonization and the air emissions. And today and tomorrow, we have assembled a number of sessions to discuss all these issues. Today, the first day of the event, we will be hosting a number of 6 sessions. We will be tackling the issues of green shipping challenges, along with some presentations, IMO, EU legislation, EEXI, CII. We're going to discuss about it. We're going to have some presentations about shipping decarbonization. And of course, we're going to discuss the issues of ship recycling by the end of the day. Now, the program today is also including at the end of the day one, the presentation of the GREEN4SEA Awards. We're going to be giving away 8 awards on a number of categories. So we would like to also, given this, let's say, opening, would like to congratulate all the shortlisted nominees, and we're going to announce and we're going to see the ceremony by the end of the day. So having said that, we would like to thank you all for joining this virtual event. We would like to thank all our viewers either today or tomorrow, or maybe in the near future. The stream, as always, is going to stay online. So we would like to thank you all for joining us in this virtual event. And of course, we would like to thank all our sponsors, along with the panelists, of course, and those who will be participating by providing some presentations. So having said all that, without any further ado, we would like to, let's say, commence with the first session on green shipping challenges. Thank you very much, and stay tuned.
Good day. My name is Ansuman Ghosh. I work for the UK Club's loss prevention team as a director of risk assessment, and I am based in Singapore. My background is of a seagoing marine chief engineer, and I have held roles in ship management, classification, and of course also in marine insurance since working ashore. I must start by thanking Safety for Sea for this initiative and for allowing me to talk on this important topic. The purpose of this talk today is to give an overview and talk about some of the challenges and how we will move forward in this green transition. Since the IMO announced its 2050 targets in 2018, the decarbonization debate has dominated many shipping industry conversations. The clock has been ticking since then. IMO's 2018 targets are aligned towards 50% reduction in greenhouse gas levels by 2050, looking at the 2008 levels in absolute terms. When this target came out, the industry voices were like, is this going to be possible? And how do we reach 50%? Not only the IMO is setting regulatory targets, but even the European Union has also proposed a challenging plan to reduce carbon emissions. Shipping is experiencing a regulatory, political, environmental, and societal pressure to decarbonize. Since COP26, there has been a shift in the dial to align with the Paris agreements. And that's very much apparent in the declaration on zero carbon shipping by 2050, which 14 states signed up during COP26. We also saw the Clydebank Declaration looking at green corridors, which was really to kickstart the process by establishing zero-emission maritime routes. The signatories plan to develop green corridors by 2025 and then scale up further. Then we have the First Movers Coalition investing in innovative green technologies. So they are available for massive scale up by 2030 to enable net zero emissions by 2050. Clearly, we are seeing the dial shift from 50% by 2050 to 100% by 2050. Further, the COSEF agreement is a coalition of cargo owners for zero emission vessels. And this is a group of end users like Amazon, IKEA, Patagonia, Unilever, just to name a few. COSEF was created because no single cargo owner can drive this transition alone. Through collaboration among cargo owners, companies, and maritime supply chain partners, COSEF aims to decarbonize their marine freight by 2040 and help catalyze entire sector decarbonization by 2050. Thus, in addition to shift of 100% by 2050, there are also voices to shift the timeline to 2040. So there are considerable challenges in the ambitions, as you can see. It is not just about IMO anymore. We are seeing end users and more societal driving pushing for alignment to the Paris Agreement. A part of it will be achieved by energy saving devices, as you see on the left, and operational savings also. But inevitably, we will need to go through an energy transition. Now, if you look back at the last energy transition, when we moved from coal to oil, we were very much moved, we were moving into a fuel which was already being transported. So it was available and was in abundance, and therefore it was pretty cheap. It was easier to store, relatively safe to handle, and had a high energy density. When we are looking at alternative fuels like hydrogen, ammonia, e-methanol, and some of the synthetic fuels, none of these offerings and advantages we had gained in transitioning to fuel oil are available with these new alternative fuels. However, they do have that critical low or zero impact, which is very important. When we look at these individual alternative fuels, each has very different characteristics. Thus, they offer themselves differently to different ship segment types, trades, and routes. So we are not going to move into an era of one fuel fits all, but we are likely to going to move into a polyfuel era, much different from today. So just in context, again, talking about the energy transition, the last energy transition took about 50 years. And as I said, we had all those levers pulling it in the right direction. We have just 28 years of this energy transition. If we are talking from today, and it's going to go through phases, as it can never be one immediate change like sulfur 2020, where we had a quick on the 1st of January 2020 switchover. It will not happen like that. For the energy transition, we need to build up to it. So today, we need to start by tightening up on operational savings, such as just-in-time arrivals, and probably looking at technologies such as air lubrication and wind sails. All this will add fuel savings. And we need to remember that future fuels will be expensive. At the same time, we need to tackle the chicken and egg scenario related to the alternative fuels use and alternative fuel infrastructure. If we analyze the need of the hour, it boils down to collaboration. The Clydebank Declaration, which is a collaboration to produce zero-emission corridors, seems to be working towards tackling this chicken and egg scenario. Such initiatives will kickstart this energy transition and build it up by creating multiple new green corridors. The signatory countries will develop regulatory frameworks and incentives to mobilize demand for zero-emission vessels on specific routes. But it is not only about ships. This is a cross-supply chain challenge, and there is a real risk that zero-carbon ships may be hitting the water before land-based infrastructure and fuel supply chain is ready. Thus, within these corridors, there will also be cooperation within the marine industry to invest in clean port infrastructure and to set up comprehensive programs for green shipping activities. Ultimately, we should see scaling up of the alternative fuels within these corridors and a cascading effect leading to gradual buildup of fuel supply and infrastructure across the corridors and then finally all around the globe. Given the international nature of shipping, there are inevitable challenges for any operator in ensuring compliance with all applicable regulations, which are likely to be complicated further by the invariably complex nature of contractual relationships in international shipping and trade. Thus, there are also contractual considerations that come with these shift towards new fuels. On the supply side, new terms and standards will need to be agreed upon, which cater for matters specific to the supply of the fuel in question. Ship managers and crew will need to become familiar with new procedures for bunkering and verifying the quantity and quality, which may also need to be addressed in the charter provisions. In terms of use, there will also be new challenges to be met by training and procedural adjustments. Fuel quality provisions will need to be carefully tailored to the characteristics of the new fuel. Fuel quality and quantity disputes, which escalated with the introduction of low sulfur fuels, may manifest themselves in different ways with the new fuels. The standard provisions for sampling and testing to resolve disputes may need to be adjusted. Apart from that, speed and performance warranties will also need to be tailored to the new fuels, and the nature of the performance disputes may also change completely depending on the type of fuel involved and the vessel's fuel efficiency as declared in the charter party. Thus, revised contractual terms will emerge for use with these new fuels in due course. Right. Moving on, retrofitting a ship costs time and money, and strategic planning is necessary to implement upgrades with minimal interruptions to operations. New technology will necessitate training for the crew, while operations and maintenance procedures will also need to be reviewed. There is also potential for design and delay disputes with yards and manufacturers as new technology is trialed. Buyers should also include watertight warranties and clear dispute resolution mechanisms in shipbuilding and repair contracts. Where possible, owners may try to cater to the potential need to withdraw ships from long-term time charters for upgrades and appropriate charter party provisions. And of course, the existing charters may need to review all these new environmental compliance clauses and off-hire provisions. And in the absence of clear wordings, disputes may arise when an owner's needs are in conflict with those of its charters. So these are the things which need to be taken care. And that ends my assigned slot. Thank you all for your attention.
Hello, everyone. This is Keith Letourneau from Blank Room, and today we're going to talk about maritime air emissions. We'll provide a few stats about maritime GHG emissions, give a brief overview of MARPOL air emissions efforts, discuss the International Maritime Organization's approach, the European Union's approach, the USA's approach, and limited progress and serious challenges that remain. So maritime vessels account for 2.5 to 3.5% of annual GHG emissions, which equates to nearly 1 billion metric tons of CO2 annually. There are roughly 55,000 merchant ships trading internationally, 15,000 general cargo ships, but there are three classes of vessels that make up about 80% of GHG emissions. Bulk carriers coming in at 440 million metric tons of CO2 annually, oil tankers at 210 million, and container ships at 140 million. Without mandatory reductions, GHG emissions from the maritime sector could increase between 50 and 250% by 2050. MARPOL is the International Convention for the Prevention of Pollution from Ships. It's promulgated under US law as the Act to Prevent Pollution from Ships. MARPOL Annex 6 addresses air pollution from ocean-going ships and has implemented both engine-based and fuel-based standards. A concern we won't address here, but is certainly paramount to masters and pilots, is how will future GHG emissions performance standards affect vessel performance. Another concern we won't address is the impact of Russia's war on Ukraine and its effect on the global maritime fleet and GHG emissions. Annex 6 has addressed sulfur oxides and nitrous oxides emissions, SOx and NOx respectively. It has established emission control areas in the Baltic Sea, around North America, and portions of the Caribbean Sea. It's required the implementation of low sulfur diesel of 0.01% by volume in these zones and 0.05% on the high seas. South Korea has also developed an ECA. With respect to GHG emissions, MARPOL Annex 6 includes Energy Efficiency Design Index, EEDI, for new build ships, and soon to come into force, the Energy Efficiency Standards for existing ships, EEXI. MARPOL's approach is to seek a 40% reduction by 2030 when compared to 2008 levels, 50% by 2050. But that 50% reduction by 2050 is still far short of the global net emissions by that same year that climate scientists say is needed to avert increasing the average world temperature by no more than 1.5 degrees Celsius in this century. So let's talk about EEDI first. This is for new build ships, and it estimates the grams of CO2 per ton mile. It reflects energy efficiency in actual use and is a function of installed power, vessel speed, and cargo carried. It's intended to ensure that new ships are designed to be energy efficient. Its current implementation calls for percentage reduction in GHG emissions from 0 to 20%, depending upon vessel type for vessels constructed through December 31st, 2024, and during the next 5-year cycle from 0 to 30%. The good news is that over time, new ships are gradually becoming more energy and GHG emissions efficient. The bad news is that the standards are not sufficient to achieve the IMO's stated goal of a 40% reduction by 2030 in GHG emissions when compared to 2008 levels, and EEDI does not address the state of the existing fleet. SEEMP, the Ship Energy Efficiency Management Plan, provides an approach for monitoring ship and fleet efficiency performance over time. In 2021, the enhanced SEEMP regulation was adopted, requiring all cargo RoPax ferries, that is roll-on, roll-off passenger ferries, and cruise ships over 5,000 gross tons and trading internationally to have an improved implementation plan on how to reach the required carbon intensity indicator, C2, from January 1st, 2023. EEXI, the Energy Efficiency Existing Ships Index, applies to ships over 400 gross tons. It estimates CO2 emissions, again, grams of CO2 per ton mile, based upon ship characteristics and mathematical equations. MARPOL Annex 6, Regulations 23 and 25 enter into force on 1 November 2022. Starting in 2023, EEXI will apply to the world's existing fleet of merchant ships, and it is expected that most of the older ships will not meet EEXI requirements. EEXI does not require any measurement or reporting of true CO2 emissions while the ship is in operation. So questions remain. How do you enforce EEXI standards? For example, if a ship will only meet its EEXI requirements by slow steaming, How do you enforce that requirement? Is it feasible to retrofit existing ships with new technologies to meet EEXI requirements? Is the payback time short enough? Which technologies will emerge as the most economical and efficient to reduce GHG emissions? How many ships will have to be scrapped? What will be the impact on tonnage capacity in various sectors of the maritime industry? What will be the impact on long-term charters, on freight rates, on decisions to sell vessels and to purchase new ones? The carbon intensity indicator, MARPOL Annex 6, Regulation 28, enters into force also on 1 November 2022. This index measures the actual CO2 emissions in ship operations, and it creates a vessel rating system of A through E, with A being the lowest and E being the highest GHG emissions. For all ships with a D rating for 3 consecutive years or an E rating for a single year, a corrective action plan must be developed and approved as part of the vessel's SEEMP. C2 is based on deadweight tonnage and not actual cargo carried, and so arguably does not incentivize cargo optimization. Permissible C2 GHG emissions will gradually decline year after year. Vessels that cannot demonstrate compliance with EEXI and C2 regulations may not be able to trade internationally. In the spring of this year, IMO will hold its Marine Environment Protection Committee, MEPC 78 meeting, scheduled for June 6 to 10, 2022. The intent is to revise IMO's initial strategy and define its long-term GHG reduction measures to be finalized with an agreed target date. IMO is entering phase 2 of its assessment period from spring 2022 to spring 2023, assessing the feasibility of measures to reduce GHG emissions. Because the IMO has not acted swiftly, the EU was prompted to act to implement actions to slow the progress of GHG emissions. It's taken a 3-part approach. The first is monitoring, reporting, and verifying CO2 emissions, which started on January 1st, 2018 for ships over 5,000 gross tons. Secondly, they're establishing GHG reduction targets for the maritime transport sector. But probably most importantly, the third element is that the EU is including the maritime transport sector in the EU's emissions trading system. The EU has the first major carbon market and remains the largest. It sets an absolute limit on GHG emissions by entities covered by the system. Maximum allowances are allocated to participants which can purchase or trade. If the allowances are insufficient to meet its needs to reduce carbon emissions to fall within its allowance, a participant can purchase further allowances that are traded on a secondary market, and the allowances are gradually reduced over time. The EU's goal is Fit for 55, 55% reduction in carbon emissions by 2030. This slide sets forth an overlay of the IMO and EU's time horizons for implementing GHG emissions, and it's worth reviewing if you have a few minutes. The USA's approach is that it will join IMO's efforts to achieve zero carbon emissions. The US Coast Guard has announced that it intends to propose regulations to implement energy efficiency measures in MARPOL Annex 6, Chapter 4 to reduce GHG emissions. It will apply to US flagships as well as foreign flagships operating in US navigable waters or the EEXI. The Coast Guard regs will be designed to, quote, fill the gaps in an existing framework, unquote, whatever that means. And the Coast Guard's timetable to release those regs is May of this year. There has been some progress, but there remain significant challenges in achieving maritime GHG reductions. Container carriers Maersk and Express Feeders have ordered the first green methane container ships. Maersk has 12 ships on order and Express Feeders has 16 on order. There are conservation measures that exist today: slow steaming, weather routing, contra-rotating propellers, and propulsion efficiency devices that can deliver greater fuel savings. Although slow steaming needs regulation to ensure fleet operators don't game the system by adding ships to the queue to make up for the lost cargo and time. Additionally, Amazon, IKEA, and Unilever have announced that they will require all of their ocean cargo to be carried aboard ships powered by zero carbon fuels by 2040. But there are still serious challenges. The cost of compliance with GHG reductions by the world's merchant fleet will be considerable. There's no real path to retrofitting the existing fleet. There's a lack of compliance standards and enforcement measures. No coordinated effort exists to facilitate the movement of vessels in or out of port. Maersk reported that the pandemic and delays encountered at ports actually caused its GHG emissions to rise in 2021. Maersk's CEO of Ocean and Logistics, Vincent Clerc, advocates for a net zero emissions by 2050, a drop-dead date for building new compliant fossil fuel vessels, and more punitive carbon tax to reduce the cost gap between green and carbon fuels. None of that has come to fruition as yet. Like this program, time is running out. We need a symphony of players to achieve the reductions climate scientists are telling us are necessary. We need the IMO to serve as composer and conductor to lead that symphony. Thank you very much.
Hello, everyone. Today, I'm gonna speak about how I think the EU ETS and the IMO CII regulation will change shipping, and in particular, the owner-charterer relationship. So, starting with the EU ETS, this is part of the European Fit for 55 package, which aims at 55% greenhouse gas reductions by 2030 from 2019 levels. The Fit for 55 package actually involves all industries, and of course now it has included shipping, and in particular it has included shipping in the European Union emissions trading system. And that was done so at the insistence of the Commission Directorate DG Klima. The Commission has many directorates. DG Klima, of course, is the Directorate for Climate. DG Move is the Directorate for Transportation. And of course, DG Move being more knowledgeable about shipping and what would be more appropriate for shipping, they wanted a tax. So the two directorates were fighting actually between themselves what to include, and the Commission wanted to have them both happy. So we got both inclusion in ETS and a substantial tax on European fuel starting from 2023. Now, what the regulation requires is that all emissions that are done by a ship within the European Union, the allowances for those emissions have to be submitted at the end of the year to the European Union. And the allowances you buy from the carbon exchanges. And then for trips coming to the European Union or leaving the European Union, you will have to submit 50% of the total trip emissions. So if your trip originates from South America to the European Union, you have to submit the allowances for 50% of that trip, 50% of the CO2 that the ship emitted during that trip. Now, who is the responsible party to submit those allowances? It is the ship manager. It's the ISM dock holder. And I don't know if you followed the news and press releases. Many shipping organizations and ship owners unions were happy to see that the new draft of the regulation includes statements about the responsibility of the commercial operator or the charter and all that, but all those are cosmetic in my opinion, because several pages down, the regulation says who is the responsible party to submit the allowances to the European Union, and that is the ship manager. So even if the charter is responsible, he will have to give the allowances to the ship manager so he can give them to the European Union. Now, usually when an industry is first inducted into the ETS, there are some free allowances, but not in our case. There will just be a gradual coverage of emissions from 2023. So in that first year, 45% of the regulation allowances will have to be submitted. Next year, 24, 75% of the total allowances will have to be submitted. And in 2025, the regulation goes into full effect. 100% of the emissions will have to be submitted. So trips to the EU will be costly, and that cost will fall on the European consumer. How costly? This is an example of a Panamax bulk carrier or a Supramax bulk carrier on a rather small trip, a 14-day trip from Americas to the European Union. This is how much it's going to cost in allowances based on yesterday's carbon price per ton. And of course, this carbon price, I have there 85 euros per ton of CO2. That was yesterday's price. It has been near 100 recently, and nobody knows that that number may be double in the future. For every day within the European Union, the cost will be at this $85 per ton, $9,500 extra. And imagine a long trip from Asia to Europe. So we're talking about huge costs because of this ETS system. So that will change shipping in many ways. I think commodity flows will change, favoring shorter trips. So for example, nobody's going to carry grains from Australia or even from USA to Europe anymore. And everybody would want the Russian and Ukrainian grains. Non-EU countries who happen to be geographically close to the EU, such as Turkey, may become EU import-export hubs. And of course, there will be a huge administrative burden, especially for the small shipping companies. Imagine having to calculate what allowances you need. You have to go to the carbon exchanges to buy the allowances. You have to submit the allowances and so on. And finally, I think that the owners will be requesting from the charterers, if they are on a time charter, the cost of the CO2 allowances in advance. As soon as the charterer orders the ship to a European port, the owner may say, okay, can you please give me so many allowances or so much money for me to buy the allowances. And longer term time charters may have a submission of allowances from charterers to owners at regular intervals, such as monthly. And I'm in a position to know that the BIMCO charter party clause that's being prepared by BIMCO specifies something like that, like regular submission intervals, because you understand if the money that's owed is left for the end of the charter, it might be a very huge amount, and the owner may be in very difficult position if the charter doesn't pay up at that time. And there is another big question in my mind. What will happen if a big ship manager, one of those big ship managers that manage hundreds of ships, does not receive the allowances for one of his managed ships, either because the owner or the charterer went belly up? Well, the answer, as the regulation stands now, is that all the managed ships by this manager will have a problem with the regulators, because the regulation is not ship specific, it is manager specific. So either the manager himself will have to fork the money for the allowances, or all the ships under management will be targeted by the European Union. Let's move to CII. Now, the nice formula you see over there is the EEDI formula. This is the formula based on which the new EEXI IMO regulation was formulated. And all I have to say is don't be afraid. EEXI is very simple despite that formula. EEXI is just a limit of the ship, a limit to the maximum power of the ship. And it's a one-time change. So it changes in the charter parties, the ship description, once and for all. Instead, let's say, for example, instead of a ship being able to do 14.5 knots as maximum speed, now after EEXI, maybe the maximum speed is reduced to 13.5 knots. But the charter knows that from now on, after EEXI is applied, the ship maximum speed is 13.5 knots. It's a one-time change. CII, on the other hand, is not that simple. CII is quite complicated. The formula for CII is practically fuel consumption divided by distance traveled. And you understand, of course, just by this formula that ballast trips are favored here, because you can have a lot of miles accumulated in an empty ship condition, which consumes less fuel and therefore emits less regulation. But that's a separate issue. You'll have to calculate this factor every year at the end of the year, and the regulation says you have to be within the C range. We have the refrigerator system, as I call it, A, B, C, D, E class. So every year the ship will have to be in the C range. Otherwise, if you are D for 3 years or E for 1 year, you'll have to submit corrective actions to class to show them how you're going to get back to C and all that. So what happens when a ship is under charter? Every year you have to be in the C range, otherwise you have trouble, which means that both the owner and the charter must keep track of the ship's performance, at least after every trip is completed, in order to be able to adjust your performance for the next trip. So that means that in the beginning of the year that the slate is clean, a charterer may be able to order the ship to go full speed at 14 knots or 14.5 knots, whatever the full speed of the ship is. But towards the end of the year, the charterer cannot do that. He will have to reduce the order speed by such an amount as to allow the ship to remain within the sea territory. So you may have a case where the charterer says, okay, for a trip in September, proceed at 13.5 knots, and the owner should be able to go back and say, sorry, you cannot order the ship 13.5 knots. Now you have to do it 12.5 knots in order to remain in compliance with CII. So the whole relationship between owner and charter will have to change. It has to be a open data transfer from the owner to the charterer to show him why he cannot order the ship to go at a speed that he could order before. And of course, you need true cooperation by both parties going forward. And I think that's a major change. It's a complicated issue. The charterer will have to start educating themselves into regulations that apply to ships, in particular CII. And I know that also the BIMCO clause on CII is trying to build up this relationship between owner and charterer. That's it from my perspective. Thank you very much for your attention.
Greetings to delegates to the Safety for Sea Green Shipping Challenges virtual conference. During the next 10 minutes, I wish to highlight the importance and role that advanced exhaust gas cleaning systems, advanced scrubbers, will play over the next 20 years in the operation of merchant ships. With some 5,000 ships now fitted with SOx scrubbers to remove SOx, data shows that this amounts to 25% of the global marine fuel bunker demand, which is consuming high sulfur fuel, or often known as residual fuel oil. As well as reducing SOx emissions well below the emissions from ships using 0.5% sulfur or 0.1% sulfur fuels, the fossil carbon footprint of a ship using high sulfur fuel oil and a scrubber is on average 10% lower. This is not my opinion. This is the conclusions of a CE Delft study. Assuming an annual global bunker consumption of about 250 million tons, ships with scrubbers are emitting some 20 million tons less CO2 than if they had not fitted the scrubbers and were burning the appropriate sulfur content fuel. That is a benefit to the globe. That is happening today, an immediate and early contribution to net zero fossil carbon emissions. I don't care when ships need to get to net zero, but shipping must achieve zero fossil carbon emissions at some time in the future. The marine press is now driven by headlines of daily news, new initiatives to achieve net zero fossil carbon emissions. But the truth is, for the moment, is that there are limited realistic options. I will only consider main propulsion and ignore power generation. After all, for most ships, 90% of the CO2 emissions relate to propelling the ship across seas and oceans. I will also consider ocean-going vessels as they are carrying the bulk of the maritime trade. In my opinion, the likely order of contribution to propelling ships in the next 20 years is from the least likely to the most likely contributions to ship propulsion as follows. Electricity storage or some other energy storage system, for example, liquefied compressed air, is one system that's being used on land to store a lot of energy and issue it again as a propulsion system very efficiently. Fuel cells are also an option. And then there is, of course, wind, nuclear, and then the internal combustion engine. Fuel cells appear to need fuel of great purity or risk damaging the exchange membranes. That is certainly applicable of the PEM type fuel cells. Wärtsilä ran a project on fuel cells and concluded that the technology was not going to be practical or commercial for marine propulsion. Wind has great potential as a propulsion supplement, possibly with energy as high as 30% of the total propulsion requirement. More work and accurate assessments need to be undertaken. Sadly, both are lacking at the moment, despite press headlines to the contrary. Whilst the various wind assist interests continue to fail to deliver verifiable data, there's going to be skepticism and reluctance to invest. With classification societies compromised over their expertise and independence, there's a real need for independent assessment out with the usual marine verifiers. And then to nuclear energy. Nuclear as an energy source in a modular, identical, mass-produced modules has a massive potential, but it must overcome some significant negative perceptions. It seems that many of the negative perceptions are primarily sourced from NGOs and so-called green thought leaders who have perhaps not the full knowledge of the technology or really assess the risks holistically. The application of nuclear will need a change in the way shipping is managed. Shipping with nuclear energy source should only be licensed and operated where the responsible parties are able to comply with strict vetting, manning, education, conditions, and have operator-owner assets allocated to ensure there is full liability cover in the event of failing to operate to the requisite high standards. I conclude by saying that the internal combustion engine will remain the main propulsion energy source for the majority of ocean-going vessels for the foreseeable future. But there is a downside to the marine diesel engine. It emits toxic exhaust gases. Again, this is not my view. This is a statement from the WHO. and diesel engines are currently use a lot of fossil carbon containing fuels. Let us first consider the toxic and harmful emissions. Some of the components diesel engines exhaust contribute to greenhouse gas buildup in the atmosphere and subsequent climate change. Other components negatively affect human health, and some components impact the environment and organisms. It should be noted that the last bastion of unfettered emissions control is shipping and aviation. On-road vehicles, off-road vehicles, mobile plant, stationary plant, power plant, all have strict and becoming stricter controls, certainly in the developed world. So ships will need to eliminate their contribution to pollution. This has got to be a priority task for the IMO. Some of the emission components include black carbon, toxic condensable compounds, methane, nitrous oxide, and metal ash, and many more. The NGOs such as Friends of the Earth and ICCT claim residual fuels are the problem. Certainly, it has been a key role of the ICCT to use misinformation and selective data to attempt to influence governments to eliminate the use of residual fuels by continually attempting to undermine the use of scrubbers. I'm not making a sale for residual fuels or for any other fuel for that matter. Fuel decisions should be driven by economic and goal-based targets. What I mean by that is the goal should be to reduce black carbon emissions by 90% from the highest levels emitted today, or even a tighter target than that. This ought to be a phased approach over a prescribed and achievable time frame, perhaps 5 years for the first reduction and 10 years to achieve the target level. And it must apply to all ships to avoid inconsistencies in owner compliance and absurd outcomes. There are now several designs of advanced exhaust gas scrubbers that can remove black carbon, fine particulate, ultra-fine particulate, as well as condensable pollutant gas compounds. The net effect is an exhaust gas which may have lower harmful emissions than the tailpipe of a Euro 6 diesel truck. But we also need to drive to net zero fossil source carbon emissions. Here again, using total life cycle approach is essential to ensure true carbon reduction and lower greenhouse gas effect in the most cost-effective way. Ignoring the inconvenient truths such as supply chain methane slip of the much publicized natural gas as a marine fuel allows companies to make claims about their greenhouse gas emissions performance, which are simply incorrect and distorted. Scrubbers enable the capture of carbon, which makes the journey to net zero more immediate and less onerous. This does not mean that all the CO2 will be captured, but a 30% reduction in CO2 emissions is an immediate and dramatic improvement which can now be achieved, albeit development work is ongoing. There's no question that carbon captured today means less atmospheric CO2 buildup and assists in limiting climate change. And this is very prosaic, as yesterday the ICCT announced that we need to reduce carbon emissions by 50% within the next 8 years. This is really challenging, and it includes pulling out CO2 from the atmosphere, not that this is what's going to be done on board ships. So in conclusions, my summary would be capturing pollutants and a percentage of fossil source CO2 is possible, practical, and could be economic today. The so-called e-fuels and nuclear are the solutions for tomorrow. With the right regulatory framework, both can be achieved in sequence. But we must curtail undue and misinformed NGO influence on governments, resulting in regulatory frameworks which eliminate a goal-based approach to environmental aspirations and targets. Thank you for your attention.
Hello, thank you very much for hosting me for this webinar. My name is Jad Mouawad. I work at Mouawad Consulting, which is a consultancy firm specialized in ballast water management. Today, I'm going to talk a little bit about ballast water management, the state of the market, the retrofit boom we are experiencing, how the situation is, equipment, installations, and I'm going to talk more about the retrofit process, the importance of getting prepared, and what needs to be considered. To start with, I would mention that the ballast water management systems market overview, where we are, how many systems we have available. As you can see from the screen, we have approximately 47 systems that are available in the market. These are the systems that I call viable ballast water management systems, which means that the equipment is available to purchase and it's in the market, and there's somebody you can talk to. There's a lot of other manufacturers and equipment that is almost impossible to get hold of, and then we disregard them from this overview. If we look, if we divide this into the main types of equipment we have, we see that we can have approximately 20 which are UV based and 14 that are electrolysis based, and then you have 13 of chemical injection, ozonation, etc., etc. Of those, it's also possible to cook down to boil down. To those with US Coast Guard type approval, those with the Ballast Water Management System Code type approval, or both. So for a person who wants to get hold of an equipment, you know which ship you want to install it at and what kind of equipment you're thinking about. It's pretty fast, straightforward to boil down the equipment to a specific number that are possible to approach and get a quote from. It's very important, and it's part of the absolutely first things you need to do when you want to consider retrofitting your ship with a ballast water management system. If we look at the situation in 2022, we have come far with the retrofit process. The uptake of ballast water management systems is going quite well. Things are moving as they should. We see actually a trend of manufacturers not being able to deliver their equipment on time. Typical when ship owners come a couple of months before the retrofit needs to happen, and then there is a struggle to catch up with that. What we see, the main issues are mainly electronics and chips and control panels and stuff like that. There is a big lack of components for those, and then what we are experiencing is that we manage to deliver the equipment part by part, put the pipes together, lay down cables and so on, and then leave the finalization and the commissioning and the testing and so on till all the other subcomponents are actually available. So we are already there at this stage, and it puts the pressure on actually the ship owner to, if you know you're gonna retrofit your equipment next year, just do the order of the equipment this year so that the maker can actually plan and you don't have any delays. It's a big challenge for us now to go back to flag, ask for a couple of months extension because we delivered 90% of the equipment and not 10%. And then on top of that, we come from a COVID-19 restriction area period where we already asked for an extension because there was COVID and we couldn't dock the ship. And so it becomes pretty cumbersome and it's very difficult. And actually ships are losing their charters because of that. And I think it's important we realize this already at this stage and go ahead and plan in advance. You know you're going to have to do it by 2024. This is when we anticipate the rush of the retrofits. Then it's important to take action now. We see in general that the small-sized vessels are the majority of ships left without ballast water management systems on board. The vast majority of the big tankers and bulkers have already installed equipment and trading with under the G2 standard. We see more and more smaller sized vessels, which means higher and higher percentage of UV-based systems being sold. But we also see a number of electrolysis-based units, especially the direct flow ones, like Headway and Elma First, also going into that market of smaller equipment. So also Tecros. So we see a movement there, but we anticipate, at least for the next 2 years, that the biggest rush will be on the smaller sized equipment. Most of them would probably be UV based. So as we discussed, identify the technology you want to use, the manufacturer that you trust and you can work with. I understand the retrofit process. Look at all the presentations, all the data available. There's plenty of it overall, everywhere. Contact people who actually have done it and you can trust to get their feedback on. Identify engineering firms, identify the retrofit yard, and then it's important you set up a process that you follow with them. It's important when you do that to consider the support during and after the installation, when you make your choice for all these partners that you would have, from the maker to the engineering to the supervision on board to the operation later on and maintenance and so on. It's very important to take all these into consideration. This is the uptake expectation. This curve has not changed. I've been putting it up for a couple of years now. The numbers are looking exactly, they're looking not exact, but it's not looking that far away from the reality. We anticipate, and we are now in the middle of this huge uptake period, and it's going to continue like this at least until the end of this year and probably the end of 2023, where the plateau will start falling down, and then going to 2025. Actually, it's 2024, but we expect some 10% of those ships to be delayed a few months and into 2025. This is the standard retrofit chart. This is something that anybody who wants to do a retrofit of a ballast water management system should be able to consider it and work through it. It's a standard process where you do your analysis, your market analysis, you identify the ships, the equipment, and you end up with 2 or 3 suitable manufacturers. It's very important that you settle down on this. You do a thorough survey of the ship. You do a 3D scanning. It's very important, and it's part of the whole process. You do the engineering. You include pressure drops, the whole 9 yard, everything. You go into the dry dock, or you can do a riding gang. We have seen riding gang, and our teams are doing it on both tankers and other than that tankers, so it's possible. It's easier at the dry dock because there's few restrictions and you have everything you need at hand. Important to have supervision during the retrofit, daily supervision. You have somebody from your team or from the engineering firm who is actually on site doing, following up the work, the progress, making reports, making sure that all the problems are dealt with there and then. And then the commissioning should be done by the maker. And as of 1st of June, the sampling for compliance is a requirement. So it's important to consider that already at this stage. Sampling for compliance means that when you have done the commissioning and everything is working fine, you need to take a sample of the ballast water to make sure that actually things are working as they should. Later on, of course, the service, maintenance, and spare parts, like we discussed, it's important to consider this. And it seems like a lot, but this is a standard process that we've been doing for like 10 years. A lot of other firms, everybody's doing it. It's important that, but it's important that it's followed. You don't take 2 shortcuts, then everything should be working fine. It's been done now for thousands of ships, and it's there's nothing difficult there. I want to mention very quickly about the operational challenges that we still see with water quality, with UV-based systems, low UV transmittance and fouling of lamps, lamps being broken. When you have large pumps, and it's not easy to control the speed of the pump by by blocking valves and so on, then it's creating huge forces in the pipes and creating a lot of structural and on the flanges, problems on the flanges and on the pipe supports and whatnot. So considering a VFD, a variable frequency drive, for those large units can be very important. Again, as always, training to do preventive maintenance, cleaning lamps, filters, doing all this love and care for the equipment is always much better than calling to repair. And have adequate supply of UV lamps and is important. For electrolysis based, we still see a lot of challenges with TRO meters. It's improving. We still see that most of TRO meters installed are colorimetric TRO meters, the HF Scientific ones. They have a challenge that it's not easy for the crew, or at least it doesn't seem like the crew is able to do proper maintenance of those, and they're always more or less always, it's more often than not, they are actually operated outside the recommended practice. And it's important that the crew understand how these TRO meters work and how they should be operated properly for the equipment to work. Low salinity, low temperature, still an issue for those electrolysis-based. Calibration of sensors is very important as part of the maintenance. Cleaning of filters is still the same. And then you need to have enough neutralizers, enough reagents. It's always important to keep a plan for this. And so far, this has been a challenge on operation of the equipment on ships. Finally, a few recommendations from my end. As I talked earlier today, start your retrofit project early. Give it 6 or 9 months. If you know already now you're going to retrofit, start planning for it, get the bids, put the orders, do the scanning, do the survey, start the engineering, and be ready. It's important that the ship survey is done not as just a 3D scanning and then move on, but actually a proper ship survey to know what you want to do, where you want to do it. And I think, and part of the experience we've done for the past 10 years, retrofitting and supervising onboard ships, daily supervision during the retrofit is at least as important as everything else, because it puts everything in place when we want to retrofit the unit. Thank you very much.
Hello everyone, my name is Marina Suzuki, working in Class NK Zero-Emission Transition Center. In October 2021, Class NK launched the Zero-Emission Transition Support Services as a comprehensive menu of services to support customers' efforts to achieve zero-emission shipping. This presentation explains what these services are. Class NK Zero-Emission Transition Support Services contains 4 menus as shown here. These are: first, GHG emissions management systems development and certification. Second, GHG emissions management tools. Third, GHG emissions verification and assessment. And last, GHG emissions reduction support. Some services are newly introduced to cater for the latest needs, while some are existing services we have already been providing. We have consolidated these available services related to the GHG reduction from ships and put them into this comprehensive service menu so that we can contribute to our customers more effectively. Today, I would like to introduce these services together with the relevant regulations. IMO in 2018 adopted the initial strategy on reduction of GHG emissions from ships with the vision and the levels of ambition as shown here. The strategy will be reviewed and revised every 5 years, in this case in 2023. It is highly likely that the IMO's vision in the strategy will be strengthened to achieve the decarbonization shipping by 2050 during the coming review. Meanwhile, to achieve the reduction of carbon intensity by at least 40% by 2030, the IMO has agreed to implement EEXI and CII from 2023. This slide shows the overview of EEXI. EEXI, or Energy Efficiency Existing Ship Index, is a framework to set certain criteria for the energy efficiency of existing ships to reduce the CO2 emissions. Based on the size and main propulsion power, a ship's attained EEXI value is obtained, which should be less than the required EEXI value. In case where the ship's attained EEXI value exceeds the required EEXI value, one or more measures should be taken to ensure the compliance with the EEXI regulations. This slide provides the status of compliance with EEXI of Class NK ships. 84% of Class NK ships subject to EEXI need actions to comply with EEXI regulations by 2023. For your information, by ship type, actions are needed for 86% for bulk carriers, 73% for tankers, 80% for container ships, and 90% of gas carriers. In order to support ship owners and operators, Class NK has developed EEXI Simple Assessment Tool called EEXI Simplified Planner, which is available on our website. By using this tool, you can estimate whether the ship complies with EEXI, and if not, you can see how much engine power limitation, or EPL, is needed, and how much the ship will slow down if EPL is introduced. Class NK also provides further supports for EEXI regulations depending on the customer's request. If you are interested, please feel free to contact us. In addition to the EEXI regulations, CII rating will also start from January 2023. CII, or Carbon Intensity Indicator, is a framework of rating of ships on a scale of A to E, based on the ship's actual energy efficiency over a year. As the basis of the rating, CII reference line becomes stringent every year in accordance with the certain reduction rate as shown in the table at the bottom. Ships are required to update their Ship Energy Efficiency Management Plan, or SEEMP, to include the items shown in this slide. Even if the CII rating is poor, there would be no penalty, such as the suspension of operation, but corrective action plan should be developed for a ship rated as D for 3 consecutive years or rated as E. In case of such disappointing results, the SEEMP shall be revised to include the corrective action plan and verified by flag administration or a classification society. As I said before, there is no penalty even if the CII rating is D or E. However, for your business activities, maintaining good CII rating will be necessary. To support the customer's CII-related works, CII Simple Assessment Tool has been developed and made available at our website. With this tool, you can calculate the CII rating of your ship based on ship type, deadweight tonnage, annual fuel consumption, and annual distance traveled. So please have a try. Class NK also provides further supports for CII rating depending on the customer's request. So please feel free to contact us. Class NK further supports the customer's proactive voluntary efforts beyond the requirements by the international regulations. We certify GHG emissions management systems from ships. For the systematic GHG emissions management, an appropriate system would be necessary, consisting of setting a target, developing measures to achieve the target, monitoring the actual emissions, assessing the progress toward the target, and reviewing the measures as necessary. And the cycle goes on. This is just an example, and such system would be different depending on the customers. We believe that this certification would build further values to your future shipping businesses. Class NK also evaluates the achievement of carbon neutrality. While the current IMO goal is the GHG reduction by at least 50% by 2050, companies are increasingly setting their ambition to achieve the carbon neutrality by 2050 due to the growing attention for the climate change. In this regard, for the customers who set the CO2 reduction target, including carbon neutrality, Class NK will conduct the evaluation to what extent the CO2 emissions from their fleet are aligned with their targets. The contents of this service can be tailored based on the customer's requests. For example, you can set your own target as carbon neutrality by the end of this century or as 70% reduction by 2030, and so on. We will also take into account the life cycle CO2 emissions of fuel of your choice and the carbon offsetting as per your needs. Lastly, we will introduce Class NK Zeta, which has been in operation from this April. Class NK Zeta, or Zero-Emission Transition Accelerator, is a GHG management tool for emission data utilization. This is linked with Class NK MRV portal, a tool to assist the preparation of emission reports for IMO DCS and EU MRV, and subject to the consent by data owners. These are the four main functions of Class NK Zeta. Vessel monitoring enables you to monitor the CO2 emissions and CII rating of each ship. You can check the current status on a real-time basis. Fleet monitoring is the function to monitor the CO2 emission and CII ratings on the fleet level. Simulation will show you the estimation of the change in CO2 emissions and CII ratings when some measures are taken, such as slow steaming. Lastly, periodical report will assist your preparation of reports by ship types, fleets, voyages, cargoes, and so on. Thank you for watching the presentation today, and if you have any questions, please feel free to contact Class NK Zero-Emission Transition Center. We look forward to working with you for the shipping decarbonization.
Good day and welcome to the 2023-22 GREEN4SEA Virtual Forum. Already in 21, I was giving a presentation about our portfolio for different applications around the engines and propulsion systems. And it was obviously in these days that also we had very good, interesting portfolio for the engine and power systems. And today I want to give a presentation which is showing why Aquametro shaft power systems are the key components for optimizing the vessel performance, the fuel consumption and propulsion efficiency, and especially with the new EEXI regulations coming into action beginning of 2023. But first, let me start with a short introduction of our company and the areas where we are working in. Aquametro Oil & Marine is a leading supplier for smart, innovative fuel metering and performance systems. And besides our fuel meter, which are known for decades, we are focusing on marine systems, especially for the engine room and the propulsion system. We cover almost 20% of all industrial oil boilers worldwide with our measuring solutions, and about 25% of the whole merchant fleet is equipped with our fuel meter and viscosity systems for main and aux engines, booster units, and boiler systems. We are represented worldwide, either via sales and representative offices in Europe and Asia, but as well with various production sites. Our competence center for marine system is located in Rostock, Germany, whereas our head office for fuel meter is located close to the city of Basel in Switzerland. So why is shaft power measurement such of an important task? Well, on June 21, the International Maritime Organization adopted amendments to MARPOL, introducing the regulations 23 and 25, the so-called Energy Efficiency Existing Ship Index, or EEXI, which are the first steps for shipping industry to move towards its target of a 50% reduction in carbon emission by 2050. Two methods have been described by the IMO that the ship can take to improve its EEXI score for the main engines. First would be the engine power limitation, and the second one, the shaft power limitation, the so-called Chapoly. The Chapoly method involves the measurement of shaft power, torque, and speed that are then fed back to the engine management systems to then limit the power in accordance with the regulations. The shaft power meter is the key component for the measuring ship performance, fuel and propulsion efficiency, the engine, hull and thrust performance, as well as for monitoring the shaft power limitation. It is designed to measure, log and report values such as shaft RPM, torque and power. It is easy to install operates contact-free and is type approved by DNV and the Chinese authorities CCS. And combined with the fuel performance systems and the monitoring, you can obtain all important data for optimizing the ship performance and fuel efficiency, as well as the ship propulsion performance. The SPM shaft power meter is the cost-effective solution when reliable shaft power measurement is required. The system is easy to install and requires no electronic parts on the shaft and operates absolutely contact-free. The shaft power system is designed for shaft diameter from 200 millimeters up to 1200 millimeters and for maximum speed of up to 800 RPM. The values you will get out of the systems are RPM, torque and power, and thrust as an option can be obtained. These parameters are valuable information for fuel and propulsion efficiency. The configuration and setting is made via a web browser, and communication is done via Ethernet connection. The main application for the shaft power system is nowadays the retrofit of existing vessels with an attractive solution in cost, installation, and commissioning. And the recent installations on retrofit vessels have shown that due to the fact that the shaft power measurement is easy to install, we can show that installations and commissioning can be done within 1 to 2 days, dependent on customer requirements and availability. So what is the theory and basic principle behind the Aquametro oil and marine shaft power system? Roughly speaking, the working principle of the shaft power system is based on a non-contact measurement of the phase shift between two sensors, 1 and 2, and 2 installed magnetic bands on the propeller shaft. We used magnetic pickup sensors and the mathematical algorithm to calculate the different parameters. Phase shift represents the torque on the shaft by the force of the propeller movement. In addition to the torque measurement, RPM, power, and optional thrust is calculated. With the precise measurement of the torque, the actual values and the ideal propeller curve can be obtained, and values are fed back to the vessel monitoring systems to do the necessary steps of the shaft power limitations according to EEXI regulations. The shaft power measurement, furthermore, allows the vessel to always be on the ideal propeller curve. Due to the accurate torque measurement, the ideal propeller curve is known for the highest efficiency at lowest consumption. So only real-time measurement and torque will give you accurate and valuable information on the condition of your vessel propulsion. So finally, I would like to show you some of our recent shaft power measurement installations, which we or the vessel crew have installed and commissioned on various vessel types. You might be surprised by my comment, the vessel crew did the commissioning, as our shaft power measurement is also designed to be commissioned by the vessel technical staff. As in the recent 2 years, due to COVID restriction, worldwide traveling by our service engineers was not that easy, and therefore we supported many vessels crews in commissioning these systems remotely via social networks or video calls. So the first example shows the recent installation and commissioning done by the staff of a US stretcher with 2 shaft power measurement arrangements for port and starboard shaft. What was special for this vessel type were the 2 measurement systems with a horizontal mounted frame. Installation spot of the frame is dependent on the spot, free of external vibrations, which could influence the measurement results. Therefore, a horizontal mounting on the side of the frame was chosen. Here you see port and starboard installation with the horizontal mounting. The next reference shows the installation on a Greek crude oil tanker, where the frame and support brackets of the pickup sensors have been installed on the bottom of the vessel frame, shown here All signals are transferred to a small electrical cabinet where the local display is integrated, which shows the value of RPM, power, and torque. An additional display can be connected so the values can be shown on the control room as well. Another recent reference from an Indian box carrier where the supporting frame was installed vertically from the bottom. Here you still can see the marking for the best spot for the magnetic bands on the shaft. Here and here as well. Note as well that not a lot of space on the shaft is required. Usually 50 to 75 centimeters are fine for between both of the magnetic bands. You will note as well that the supporting frame of the sensors has no standard length and therefore will be produced according to the vessel shaft arrangement. To do so, we ask the staff in advance for some technical and design data of the shaft to find the best spot for the shaft power arrangement. The next slide shows the installation on the vessel MS Berlin from Scandlines. And this was a commission which was done by our own technical staff on board of the vessel at Rostock port just recently. The vessel is a ferry operating between Rostock, Germany and the port of Gedser in Denmark. So our crew used the crossing between the two ports, which takes usually 2 hours for a single trip, for commissioning and sea trial. Special as well in this case was the connection of the shaft power system to our own fuel performance systems for visualization of all data and calculation of the necessary KPI. These pictures show the overhead installation of the frame on a Danish container ship. We'll see that the brackets are coming from over. Again, here space from the bottom was limited and the spot from the above of the bracket had to be found. Last but not least, the reference here shows the installation on a German Balker with a very short bracket mounted from the bottom of the vessel frame. As the shaft power system is a modular system, it can easily be adopted to every area of installation. And even after delivery of the shaft power parts to the vessel, modifications on the bracket and sensor positions can be made within shortest time. With these final installation slides, I come to the end of my presentation, and I want to thank again the organizers of this event for giving us the chance to show why the shaft power measurement is of such importance and why the shaft power measurement is an easy to adopt system, especially for retrofit to meet the EEXI regulations. If you need additional information on technical aspects, references and cost calculations, I would ask you to contact either our German or Swiss office or the closest Agro-Metro Oil and Marine representation near to you. With this, I want to thank you for attending and supporting the forum and wish you all a healthy and safe time. Thank you.
Hello, my name is Panagiotis Psycharis, and I work in the environmental department of Prime. My main role here is that of vessel and engine performance data analyst, while I'm also responsible for the application of the latest IMO decarbonization regulations to our fleet. And basically any other project related to energy efficiency or reduction of our environmental footprint. So my presentation today is divided in two parts. The first of which is related to the calculation of EEXI and CII, two acronyms that we all have heard of. While the second part is a more general discussion on the data challenge that companies face on a daily basis. So this is the general form of the EEXI formula, which looks very intimidating at first, but for most vessels, it is reduced to this simplified one. The value of EEXI is significantly reduced for ice-classed vessels, and especially if they have a strong ice class, due to the contribution of the factors that are highlighted here in blue, which are FI and FM. But in general, the most important factors for all vessels are the reference speed, highlighted in red here, and the spoke of the main engine, highlighted in green. These factors play a vital role in the EEXI calculation, and they have to be selected very carefully. When the calculations of EEXI are complete as per the formula presented in the previous slide, the attained figure must be less than a required figure, which only depends on the vessel's type and deadweight. In case of non-compliance, or in other words, if the attained EEXI is greater than the required one, the most dominant solution is the engine power limitation, or EPL. EPL can be calculated by simply reducing the engine power by very small increments until the attained EEXI is less than the required. In this iteration, in this iterative process, the only variables that are affected by the small changes in main engine power are the speed and the spoke of the main engine, while all other figures remain constant. If we had to select the most important factor, that would be the speed, the reference, because the proper speed power curve selection can improve EPL by up to 50% compared to the default statistical method presented in the regulation. Contrary to EEXI, CII is an operational measure which is calculated on an annual basis. CII is directly related to IMO DCS and therefore the annual efficiency ratio, AR. The CII calculation process for a vessel begins with a calculation of CII for the reference year 2019, which is given by this formula. A common misconception is that the CII reference is related to the vessel's AER on 2019. This is wrong. The CII reference curve was determined by fitting a curve to all the AER data of the industry for 2019, one curve for each vessel type. So as per this formula, CII depends only on the vessel's deadweight and type. Coefficients A and C vary per vessel type. So when CII reference is determined, it is multiplied by a reduction factor in order to calculate the required value of CII for a specific year. Then, depending on how bigger or smaller the verified AER of the respective year is compared to the required CII of that year, our vessel receives a rating from A to E. So now let's look at an example. As we said before, our vessel's CII reference is calculated once, since it only depends on the deadweight and vessel. This is a constant value. Then a reduction factor is applied every year, which is increasing every approximately 4 years, as we can see here. Aggregating each year's reduction factor results in a total reduction factor with regard to 2019. Then multiplying this factor by the CII reference that we see here yields the required CII for each year. Then lines 1 to 4 are determined based on this required CII. At this point, we must note that the reduction factors from 2027 and onwards have not been finalized yet and may change in the future. So the main takeaway from this example is that the whole CII map that we can see here does not change in time. It's static, and it only depends on the vessel. It is a vessel specific map. So this map does not depend on the AER of any year. It depends just on the deadweight and the vessel type. So when we create this map, then we can plot, we can insert our AER figures and find our vessel's rating. So in this indicative random example, the vessel receives a B rating in both 2019 and 2020, since the AER values are between lines 1 and 2. So below line 1, the vessel would receive an A rating, while above line 4, the vessel would receive an E rating, and between lines 1, 2, 2, 3, and 3, 4, the vessel receives ratings B, C, and D respectively. In Prime, we have developed our own tools for its regulation. Our EEXI tool is designed for tanker vessels and calculates all the possible values that EEXI can take depending on different speed scenarios. So through this tool, we understood very well the effect that the speed power curve has on the regulation and how speed sensitive the EEXI is. A clean picture of the gain from its calculation method helped us make the right decisions for improving our vessel's CII. Then our CII projection tool enabled us to understand the impact that the operational profiles of our vessels have on CII. The tool has various projection options which allow us to benchmark our fleet against the past and gain insights on what the future is going to look like. Now, in the second part of my presentation, I would like to focus on data acquisition, analytics, and data problems that we face. Companies mainly gather data from new reports and automated data from onboard sensors, which are installed on the vessel's machinery. In Prime, we use new reports and both automated data that are installed in the primary and the auxiliary machinery, and we have developed business intelligence tools that summarize all this, that take all this data and summarize them into valuable analytics. We do support AI, and we believe that shipping can and will benefit from AI application, especially under the perspective of the upcoming CII regulation. Voyage optimization through automated data acquisition and AI can be a first step towards decarbonization before the application of any other novel design or alternative fuels. So while the proper use of AI software and automated data can yield considerable fuel savings and key insights, there are big problems with non-reporting. IMO DCS and EU MRV are mandatory regulations and have to be reported on a yearly basis through the collected non-reports. These reporting schemes include all the non-reports of the year. No single data can be excluded. Non-reporting involves the human factor, and therefore misreporting is very usual. A lot of working hours are wasted for the correction of this report, both from the office side and from the seafarers. The industry needs tools that strongly validate non-reports and leave no room for erroneous reporting. Due to the upcoming CII regulation, we believe that CII will complicate the IMO DCS verification process due to both the importance and the impact of the CII rating on a vessel, and also due to the increased number of parameters that will have to be reported and verified. We believe that we are now in need of better non-reporting tools more than ever. Thank you. This concludes my presentation.
Good morning to everybody. Thank you very much for the invitation. My name is Iason Zacharioudakis. I am holding the position of Operational Technology and Energy Management. Our presentation deals with the environmental regulations that have been already in place or will be soon, their implementation, as well as the challenge that we are going to face. In the first slide, a timeline is presented starting from 2021 up to 2050 with green bullet zones related with significant environmental milestones. As we can see on the screen, by 2050, the European Committee requires EU to become climate neutral. 20 years earlier, in 2030, which is not far away from now, the Fit for 55 legislative package looks for a greenhouse emission reduction by 55% compared to 1990 levels. The same package requires European emission trading system, well known as ETS, to introduce and include maritime sector, starting monitoring of emission from 2023. Apart from the EU ETS, China has recently launched a similar mechanism back to 2021 without including, for the time being, the shipping industry, while there is a significant number of smaller in volume mechanisms that are in force or under development and configuration. The high number of ETS does highlight that this kind of mechanism might have a significant role in the green transition. On the other hand, we can see the IMO limits that are less driven. By the year 2050, IMO requires a 50% and 70% reduction of greenhouse and CO2 emissions compared to 2008. On 2030, the CO2 threshold has been dropped to 40%. The very recent measures that IMO has introduced for reaching these levels are the Energy Efficiency Existing Ship Index, which is well known as EEXI, and the Carbon Intensity Index, CII, that both are entering into force, as we can see on the screen, at the beginning of 2023. It is very important to highlight at this point that IMO will assess the effect of measures in 2026. As has been mentioned before, the EEXI is one-off technical measure that can be applied either through the limitation of engine or shaft power. Unfortunately, we have noticed lack of solid interpretation from Ajax, and we have identified gray areas that need to be further illuminated despite the very recent circulation of relevant guidance documents. The lack of required clarity in EEXI regulation has resulted in delays in certification process for the proposed solution from major players. Although EEXI is one-off, the EEXI is expected to affect the operational profile of vessels, mostly vessels with high sailing speed. On the other hand, the carbon intensity index, known as CII, is a measure of variable threshold that requires continued monitoring and a correction plan in case that vessel fails to comply. The CII is expected to affect in a greater intense vessel operation, given that their environmental performance should be always improved annually compared to the previous year. Needless to say that their performance can be easily affected, both in positive or negative way, from current market demands on delivery. Passing to the European field, the Fit for 55 package that was introduced back in 2021 is coming to contribute to the targets of Green Deal. The Fit for 55 presents 12 legislations that are focusing in the reduction of greenhouse emissions. 4 are strongly correlated with the shipping and the achievement of gas reduction limits in 2030 and 50. The European emission trading system is the first one, a mechanism that will monitor and properly weight all the intra-EU voyages. Emissions permits will be necessary to be taken from the market and next surrender on an annual basis based on the last year environmental performance of vessel. The Fuel EU Maritime regulation is another tool that will introduce by 2025 the life cycle greenhouse gas footprint on every fuel on board. Subject rule is considered as necessary for the propagation of net zero carbon fuels on board. Furthermore, the alternative fuels infrastructure regulation is expected to benefit and fuel the development of necessary infrastructure for alternative fuels such as LNG and makes electricity available in major EU ports. A number of EU-funded ports, such as Eeling, is leading to that direction with cold iron. Last but not least, the Energy Taxation Directive is coming to set the rules in the environmental union market against best practices and set rules for good competition. Such regulation is also expected to assist in reducing the premium on the alternative fuels price. But which are the challenges? One of the major challenges towards succeeding environmental compliance is the data integrity. The technical operational measures and mechanisms that have been introduced are very well based on field measurements, such as fuel consumption and travel speed and distance. It is absolutely necessary data to be reliable and online with their transmission at shore to follow a reliable transmission protocol. We cannot get improved if we do not firstly define the critical parameters and we do not next measure them with high accuracy. Said approach will enforce the transparency of environmental performance indexes and allow much more reliable comparisons between vessels, fleets, but also and companies on commercial web platforms. Although the demands are fluctuating and continuously becoming more intense, the regulatory framework, when it is introduced, should be solid enough and maximum clarity to characterize the requested actions. For instance, the EEXI regulation is still a framework that requires further clarification, although the effective date is really reaching us. There is a continuous trend to operate in greener and thus more sustainable way. This need imposes the necessity to adopt the more innovative energy-saving technologies and designs from the very beginning of vessel life. Innovative technologies are also required from existing vessels, and synergies with other sectors, such as aerospace, is required for our success. The propagation of renewable sources of energy, the new energy means such as ammonia, liquid and gas hydrogen, the utilization of fuel cells instead of thermal engines will surely occupy a lot of our future time and will eventually contribute in our energy independence and greener vessel operation. The alternative fuels such as biofuels, LNG, ammonia, hydrogen, electricity do show us a way for meeting our green targets, but there is still a significant distance to be covered before become techno-economically feasible. The lack of infrastructure, the very hard logistics, transfer storage, the very high premium price need also to be improved, enabling the smooth transition to greener fuels and make them a feasible option. Thank you very much for your time. Thank you very much.
Good morning, good afternoon, everyone. I would like to welcome you to this presentation, which is regarding the energy efficiency index and for the ships and the carbon intensity indicator. I'm Nikos Melachropoulos. I'm a mechanical engineer at MSc, and I'm a technical consultant of the Ship Owners Claims Bureau, managers of the American Club and Igoumenitsa Marine. I have been in the shipping industry for approximately 23 years, 5 of which working as superintendent and fleet manager, and then for 18 years as surveyor, reaching up to the principal surveyor in the international consultancy firm. So today's presentation refers to these two, the energy efficiency index and the carbon intensity indicator. Actually, we are all aware of the climate change, which is upon us practically, and the IMO could not be absent of this. And in this context, IMO has taken major steps, the most significant of which is the establishment of the greenhouse strategy, which targets to the reduction of emissions by 40% by 2030 and by 70% by 2050. By setting in force these two new regulations. And until the greenhouse emission strategy is fully deployed, the target is for the total annual greenhouse gas emissions to be, from the maritime industry, to be halved. So what is actually the energy efficiency index? This is a value applicable to all ships above 400 gross tons, and used to determine the technical and design efficiency of a vessel in order to comply with the forthcoming regulations. Each vessel has to present the energy efficiency index after the first renewal, annual or intermediate air pollution prevention survey, or in the initial energy efficiency survey after the 1st January of 2023. And this has to be calculated and recorded and remain in the ship's documents. So how to calculate this? This is the formula, as you can see. Okay, we will not go into so much mathematics, but we have to keep in mind that the main parameters that affect the energy efficiency index is the power of the main engine, which is P&I, which actually the 55 refers to the 75% of the maximum continuous rating of the engine. And this also applies to the auxiliary engines as well. Then the other important parameter is the vessel speed. This is taken from an estimated speed power curve, which is defined practically in the MEPC resolution and the relevant guidelines, or from a sea trial report via relevant formula using sea trial service speed, dead weight, power of the main engine. If such data are not available, then we use statistics to get the vessel speed, which is actually the statistical mean of distribution of the ship speed and engine power via also, again, a relevant formula. The other parameter is the specific fuel consumption, which should be interpolated by using consumption values as listed in an applicable test report included in an approved technical file of the main engine. CF in this formula is the correction factor between the fuel consumption and the carbon dioxide emissions. The F factor shown in this formula are actually also correction factors, which actually depend on the ship's type and size. So having seen how the energy efficiency index is calculated, we can see that this, as we mentioned before, comes into force into 2023, and with the requirement to comply by the end of that year. Then the plan is to be revised 2 years later in 2025, and from this mid-term, short-term practical course of action, it appears that more than 30,000 vessels will be affected in total. Having seen now the energy efficiency index, then the second parameter that we're discussing in this presentation, the carbon intensity indicator. This is the carbon intensity indicator is an operational index practically, which is used to determine the annual operation efficiency of a vessel, which is based on carbon emissions, the dead weight of the vessel, and the distance that the vessel sails annually. It applies to all vessels above 5,000 gross tons, and in order to be in a position for a vessel to determine this annual operational efficiency via the carbon intensity indicator, and a ship energy and efficiency management plan should be implemented by the vessel. The carbon intensity indicator is practically a part of the IMO data collection system process. Each vessel is mandatory to report all emissions via this system, the data collection system. Reporting all the emissions annually, then we have the annual efficiency ratio calculation. This ratio is calculated based on this data, and depends also on the type of the vessel. So the formula to calculate basically is dividing the CO2 emissions by the dead weight and the distance sailed for some types of the vessels, or the CO2 emissions divided by the gross tonnage or the distance sailed for some other types of the vessels as sailed. Getting this data and calculating the annual efficiency ratio to then have the rating of the vessel via the carbon intensity indicator. As you can see, this is a rating starting from A to E, A being the most environmental friendly, and the highest pollutes is rated as E. The baseline of as we said, it comes into force into 2023, but the base here is set to be the 2019, and based on which the target is to achieve a reduction by 5% on 5% reduction in the emissions by 2023, and each subsequent year 2%. So this means that by 2024, the vessel should demonstrate a reduction in the emissions by 7%, and 2024 by 2025 by 9%. Important factor also to note is that from its implementation, and if the vessel gets a rating of D for 3 consecutive years, or at any year the rate of the vessel is E, then corrective actions and steps has to be taken and actually update the ship energy efficiency management plan in order to improve the rating and targeting to at least the benchmark of C, or even better if possible. So, as we have discussed about these two indicators, let's see, practically the differences is that the energy efficiency index is a design and efficiency indicator, whilst the carbon intensity indicator is an operational measure to see how the ships are, to see the efficiency of the ship. So the energy efficiency index is calculated once per vessel's life, whilst the carbon intensity indicator is calculated, is taken out annually, which shows that it's practically an ongoing task in order to have for the owners and the vessels to run their vessels in an eco-friendly mode. And what happens if the vessel does not meet the targets? There are certain measures either on the energy efficiency or in the carbon intensity indicator. There are certain actions that can be taken towards this direction, and this is practically referred to three, four directions. As you can see, this is possibly limitations on the engine performance, lower limits on the engine or on the shaft in order to reduce the consumption. Another factor, another direction could be to optimize the design or the hydrodynamics using energy-saving services like shaft generators, duct propellers, etc. Of course, the monitoring of vessels' performance and the data, consumption data, is always a target and is always a task. Maintenance of the vessel on time, and obviously dry docking, hull cleaning, and overhauling of the engines are also actions to correct or to improve the rating and the outcome. Finally, another important parameter and corrective action that has to be taken care is that to optimize as practically possible, obviously, the operational parameters of the vessel, avoiding harsh weather conditions or staying a lot of time at anchorage standby. So it's a duty of all of us involved in the maritime sector to respect the event. So I would like to thank you for your attention.
Hello, everybody. I would like to present a very small scale case study about the port energy upgrade and as we apply it in the port of Igoumenitsa. But let me go in the more general approach first. I will discuss the challenges of modern ports. What is a holistic energy port upgrade? I will discuss a little bit the regulation, which is a big problem and a facilitator. And then I will just briefly mention the case study. What are the modern port challenges? The major problem with modern ports is that you have many vessels that are concentrated in a very small area. Usually the ports are near large urban centers. The local topography at times is such as, for example, in Piraeus, where you have mountains all around the port that do not allow the visible or the invisible pollution to escape. And one of the major problems is that generators are operating outside the optimum region, the generators of the ships. For example, if you see here the signature, the operating signature of a generator, although it's designed to run at 75% of MCR, maximum continuous rating, they usually operate at 25% or at much lower loads, which means that their operation is inefficient. And then the ships that use these generators have very large energy requirements, which means large emissions. A normal bulk carrier cargo vessel may need something like 300 kilovolt amperes, 3 megavolt amperes. But if you go up the pyramid, you have more vessels that are more polluters, like containers, tankers, and on top you have the cruise vessels, which may require 10 to 15 megawatts of power while berthed, just for the hotel accommodation. This, and if you have 4 or 5 vessels berthed at the same port, that means you have emissions from 60 megawatts of power. In this map, you will see we have collected the energy requirements of vessels that are berthed in almost all European ports. And this is a sort of a service that's available from the university. We have done this in cooperation with ETH in Zurich. But this is just to show how much energy is needed in a port. And of course, there are other problems. The ports need to provide innovative services with high economic and environmental impact. Onshore power supply, that means these polluting vessels should turn off their generators and be powered from ashore. This is one of the problems. But in the future, the ports will need to provide charging to electric vessels, what we call electric bunkering. They may also need to charge vehicles that are parked, normal vehicles parked at the port. And if they use some sort of renewable energy power or regenerative braking for the production of energy, then they will also need to have energy storage. And then the grid, the electrical grid of the port will need to be integrated to the city port, which means that you have a smart microgrid with a two-way energy flow, because the grid of the port, or the energy production of the port, or the energy consumption of the port will complement the energy consumption of the city where the port belongs. The ports become eventually energy hubs. That means they also participate in energy trading, buying and selling electricity. All these problems require a novel approach to how energy is managed at the port. And this is what we call a holistic energy upgrade of a port. That means creating a platform where every system that consumes or produces energy is plugged in a digital platform that calculates what is the best way to handle this energy flow. And we're talking about the capacity for bunkering, charging vessels, the capacity for giving power to vessel, the production of energy from renewable energy sources, for example, photovoltaic panels on top of buildings, maybe some wave energy generation, some wind turbine. We're talking about the energy that is needed for reefers as a consumption, the lighting, warm or cold lighting, the power that's produced by regenerative crane braking, and then you also have the full energy management, of course, buying and selling electricity from some energy provider. All this contracting and all this flow of energy should be handled by an optimized platform. And this is when we're talking about energy upgrade, holistic energy upgrade, this is exactly what we mean. One place to handle everything. And this has been done by our team, starting from the very basic onshore power supply, for example, in the port of Kyllini, a system that has been already installed, to more advanced platforms, either this platform developed for the port of Igoumenitsa, or cold ironing facilities in all major European ports. And of course, our team also participates as a university to various fora that produce the regulation and produce the standards for this electrification. The benefits of such an upgrade range from social to economical. In terms of social and environmental benefits, we're talking about improvement in public health, reduction of emissions in ports, zero-emission solutions and use of renewable energy sources in shipping and the port sector, reduction of noise, which is also a very large pollutant in a port, improving the quality and the benefits for the people that are in the port, for the tourism and the trade, increasing employment because of the new technologies, and of course, compliance with the current and the future regulations, which we will see in a little while. In terms of economic benefits, this is a win-win situation because the reduced energy consumption or the optimized energy consumption also reduces the cost of operation. The port is integrated in the area grid. We're talking about a smart grid. We're talking about the preparation for serving electric and hybrid ships. We're talking about sustainable shipping, especially for small and medium distances where we expect shipping to be almost fully electrified. Development through and competitiveness through the adoption of new technologies, trading activity in the port, which also increases its competitiveness, and of course, increasing of the energy efficiency of the port. I have here a very important graph which shows what has happened in the land and what is happening in the ship industry. As you will see in the red bars, you will see the emissions in terms of CO2, NOx, SOx, and particulate matters from land-based energy production. The red bar is for 2016, the green bar is for 2019, and you see what has happened for the reduction of emissions. On the contrary, for the port and the vessel sector, we haven't seen anything yet, but the new regulation will certainly require specific measures and very significant measures to be taken. The regulation now, we're talking about a plethora of regulation that ranges from the MRV for the monitoring, reporting and verification of for the global sulfur cap from 2020, the known EEXI and CII indices, but we're talking also about the EMSA guidelines for onshore power supply, the IEEE standardization also for onshore power supply. We have the directives from 2014 about the deployment of alternative fuels in general for every application. We're having the common rules for the internal market of electricity from 2019, another EU directive. Recently, we have seen the Fit for 55 and the Fuel EU directive. And if this sounds like small names, only the Fit for 55, they represent a set of directives of which at least 5 concern shipping directly, how it is used, how energy should be used, what ships are affected, when they are affected, etc. And then we have the biggest problem, which is the regulation for the port that and the commercial model that the port can adopt. Because of the general energy requirements about unbundled activities for trading and handling power, which means that the grid operator and the trader should be 2 different legal entities, that means a port must decide how to adapt to this situation. A port that owns the grid cannot trade energy. On the other hand, if a port trades energy, they cannot be the owner of the grid. And this is a major problem that needs to be solved. There are ways to deal with this. It's not entirely easy or straightforward. And this also means that if the state, or at least the European Commission anyway, that produces directives want to promote the use of electricity, of clean electricity for energy production, they need to solve through derogation, through other motives, such problems. So in this case, the regulation not only assists, but also presents a bottleneck, a hurdle in the adoption of electricity for energy production. We have applied these principles closely, I would say this, in the port of Igoumenitsa, where we have developed for the port, the project is currently finishing. We have developed the design for the platform, which needs to be built for the holistic energy upgrade of the port, one of the core ports of Greece with international traffic. And this platform handles all activities in the port, and specifically, at least for the time being, the onshore power supply for the port, battery swapping for using vessels that use batteries for charging, electric vehicle charging stations, energy storage, energy management through the platform, and of course, the cost-benefit analysis for these activities that the port will need for future application to the Connecting Europe facility in order to implement the infrastructure, the hardware that required for the application of onshore power supply. This is, for what effects it has, a very small project in the area of 1 million euros, funded by the Connecting Europe facility. And the participants, except for the port of Igoumenitsa, is the Hellenic Electricity Distribution Network Operator, the EDE, Protesis, which is an engineering company focused especially on electrical applications, Hees Engineering, which is the major Greek maritime consulting company, and of course the National Technical University of Athens, the Laboratory for Maritime Transport, represented in this project by myself and my colleague John Grosalidis. Thank you very much for your attention.
welcome to the panel discussion about the air emissions. We have started the day with a number of presentations regarding green shipping challenges, and followed by focus presentation, and of course a number of presentations on IMO, EU, EEXI, CII. Now it's time for a discussion part. Now, I'm sure all of you and all of us, I would like to say, the whole industry is concerned about what is going on a regulatory level, as well as on a practical level, on a day-to-day basis with ships operation, among other things like the pandemic, the Russian-Ukrainian warfare, and so on and so forth. Now, we have assembled a panel of experts to discuss the issues of air emissions. And let me briefly introduce them. We have Dr. Edmund Hughes, who is the director with Gramann Associates, Dr. John Kokarakis, who is the technical and business development director for Southeastern Europe and Black Sea and Adriatic Zone for the Bureau Veritas organization. We have Panos, who is the technical director with Sea Traders. We have Miltos Messinezis, who is a sales engineer with Ocean King Technical and Trading. Mark Smith, who is the loss prevention executive with North of England, the P&I Club. And last but not least, Stella Spiras. Stella is an environmental expert with Marina Classification Society. So I would like to thank you all for joining us. And we have a number of, let's say, topics on the table. As climate change is a key concern for sustainable shipping. And IMO, among other industry stakeholders, such as EU, such as other countries as well, has set ambitious goals. Specifically, IMO has set goals starting from 2023, with ships need to calculate their EEXI and establish their annual operational CII ratings. In addition, operators should have in mind that important milestones for EU MRV, IMO DCS are coming in the first half of 2022. And of course, there's a number of issues on the table regarding EU Fit for 55, a set of 12 pieces of legislation proposed back in July 2021. And of course, we have the so-called EU ETS on the table as a regional MBM issue. Now, I would like to thank you all, and I would like to start the discussion. I would like to ask you to address what are your key concerns with all these issues regarding regulatory compliance, let's say, in the near future. I would like to hear from you, and then we'll set the discussion and discuss all these issues that are on the table. Let's hear from John Kokarakis. John.
Thank you very much, and good afternoon to everybody. Thanks for the invitation, Apostolos. We are faced with one more tsunami of regulations coming from many different sectors. We have, of course, the IMO, who sets the pace of the world regulations, but also we have regional ones like the EU Fit for 55. The challenge is to avoid conflict among the regulations and achieve the strategic targets, which of course should be coordinated and harmonized. IMO has set the short-term measures to initiate the pathway towards decarbonization, and this is a step to the correct direction, expecting to have some results, not so much dramatic effects, but nevertheless, it's going to be a reduction in emissions. So we hope that these regulations will push the stakeholders in shipping to become greener, and this is the final target. Thank you.
Thank you, John. Stella, your thoughts?
My thoughts, actually, I believe this is a climate emergency. Scientists have confronted all the studies saying that we need to take actions for the human well-being and the health of our planet. So to the scope of these regulations affecting our industry too, the maritime industry, will help to finally get to the goal of zero emissions from ships. Actually, during all this, in the introduction of all these regulations, I believe we need to ensure a smooth transition because sustainability is also a key factor for businesses. We don't want to, let's say, see ship managers or ship owners not being able to adapt to this new environmental challenge. And the harmonization of all these schemes is necessary.
Thank you, Stella.
Thank you.
Panos, your thoughts as you are from the ship manager, let's say, side.
Apostolos, from ship manager's perspective and from shipping company perspective, the major issue is the uncertainty, because actually with shipping is already an industry with ups and downs and with much uncertainty. And with these regulations, we have the feeling that this uncertainty is increased because we have no idea what we will have as new regulations in 2026, in 2030. Supposedly, EEXI was an easy measure that we can easily comply. Now we understand that in 2026 will be a revision, whether it will be revised EEXI for all ships or for some ships, we don't know it. It is certain that ships' life may be expected, may be changed, may be shorter. So all of these parameters and all these regulation, unknown regulations that are to come and revisions that we will see in the next years, adding into the uncertainty and to this difficult environment in ship management in the ship owners in general.
Okay, thank you, Panos. Miltos, your thoughts?
Yes, good afternoon to everybody. I apologize because I had a connectivity issue and unfortunately I could not hear the position of the previous speakers. Thank you, first of all, for having me in this panel. Some key challenges I consider myself is that we don't have a common framework. We have IMO, we have EU with their upcoming more stricter regulations for the time being, as it seems. We have USA EPI that will also join the game as time comes, as well as, of course, the technology issue and the very big fact that we don't have one solution fits all ships and all types of ships. I mean, we have short sea shipping, which has to go on one way. We have deep sea shipping, which has to go on a totally different way. Of course, all this will be very tricky to overcome, and we have a big challenge ahead of us.
Thank you, Miltos. Mark?
Thank you, and thank you for the opportunity to speak here. I'm going to put the challenges as the 3 C's, to be honest, and please allow me to name them and elaborate on each point. The first one is confusion. And I think that's been touched on by Panos and Miltos, and I totally agree. You know, ship owners are a little bit unsure where they need to go. The guidelines, the regulatory requirements are constantly evolving, and to the point that we're seeing as a P&I Club, lots of questions about what's going on and what's going to change in the future. Even the EU ETS, as we spoke about, is subject to change within the forthcoming period. And then, all right, the EEXI is a little bit more settled down, but as Panos mentioned as well, that may be subject to change in 2026. We've got the CII. There's a little bit of confusion about well-to-wake analysis. You know, we really need to bring that into the training and into the equation. And, you know, apart from the confusion point, the biggest challenge as well is collaboration. You know, we need to see collaboration across all stakeholders, across everybody in the industry, and not just, you know, some parties keeping their information and their valuable insight to themselves. And last, but definitely not least, is crew training. We really see this as a challenge. You know, there's a necessity to change the fuel types on certain vessels. We just don't have the experience or the expertise or the training developed for new fuels such as methanols, ammonias, or even other fuels of that nature. So that probably passes me nicely on to Edmund, because I know Edmund's become involved with Warsash, and that is really where we need to start the training with the cadets. So I'll pass over to Edmund with that. Thank you.
Okay, thank you. Edmund? Edmund, you have to unmute.
You're right, I do. Thank you. You'd have thought I've learned by now. Yes, and thank you very much, and good afternoon, everybody watching and listening in. And thank you very much for the invitation to participate in this panel. Yes, indeed. I mean, I'll pick up on Mark's last point about crew training. Indeed, I mean, we are looking at a real revolution, really, in terms of how crews are going to have to manage fuels and energy on board their ships, and really, you know, it is difficult because of the confusion also Mark alluded to, because and difficult for ship owners, ship operators to identify, you know, what their cadets need going forward, because there is still that great confusion about and uncertainty about what the future may look like. But there's certainly something that the training institutions are and yes, and Mark probably alluded to. I'm supporting Warsash in a role now, and those institutions are clearly understanding this change is going on. They need to therefore train and their crews, their cadets, to meet those challenges going forward, and for those crews to also sort of be, if you like, risk managers of the future, because we're going to see greater risk, frankly, and I think that's one of the big challenges. Whether it's the risk of operation of the ship, whether it's risk in terms of and going further up the chain, where it's risk in terms of management of the ship. You know, we've heard about the CII and the implication of that on operations. Whether it's going to be even the construction of the ship and the financing of the ship. These are all going to, and the chartering of the ship. They're all going to have risk involved to them. So that's the big challenge for me.
Yeah. Thank you all for, let's say, outlining what we hear more or less. I would like to also add, because I think no one touched upon the cost of compliance. At the end of the day, ship management should be a profit-making exercise for all of us, otherwise there would be no shipping. And at the end of the day, we have to remind ourselves that someone has to pay the cost for all this decarbonization exercise. And that would be, let's say, the end user who is, let's say, buying a toy in some outlet in UK or in the US, because someone has to pay the fuel for this container and so on and so forth. There are issues with retrofitting plans. No one is talking about for the time being. If we're talking about, let's say, either EEXI or CII issues, talking about, let's say, soft issues, to put it in that sense, but we may be talking about retrofitting or heavily retrofitting. We're talking about new builds with extensive equipment that costs serious numbers. We're talking about the lack of common, Miltos touched upon lack of common compliance standards and common framework, as Miltos put it, absolutely. And there are issues within the industry and outside the industry, talking about leadership, because there are too many stakeholder types involved across the industry. Edmund correctly pointed out there's a full spectrum starting from the shippers, you know, those who are carrying, those who are stakeholders, those who are legislators, and of course involving ship managers, among other things, and so on and so forth. And we're going to be talking later on about the EU Fit for 55 and the EU ETS, who are talking about the burden of compliance has to stay with the ship manager. What about the ship owner? So there are a number of issues involved in this, where we are facing a complex, let's say, issue of stakeholders that have to, let's say, navigate through this tsunami, as John correctly pointed out. Now, in order to, let's say, streamline this discussion, I would like to take each topic each time, starting with EEXI and CII. Let's put it together. I would like to ask you, what are your key considerations specifically with EEXI and CII? And of course, I would like to ask on a second stage, how effective do you feel that these measures will be, and what sort of improvements you expect to see in the near future? Absolutely. everyone would like to hear your thoughts about that. But let's start with your key considerations. John, your thoughts on the EEXI and CII. Let's put one issue at a time, because it's a rather complex issue to address everything at once.
We have to remember that EEXI is a technical measure. It's related to design, whereas CII is related to the operation of the vessel. So there are two completely different things. EEXI, we comply once, and hopefully we forget about it. CII, we have to, it is going to follow us all the time. Nevertheless, measures that are taken to improve and comply with EEXI will apply also to CII, because if we put an energy-saving device, if we utilize low-friction coatings, anti-fouling coatings, this will also help to reduce the CII as well. So EEXI does not have so dramatic effect on reduction of CO2, but CII, because it's absolutely related to operation, has more effect. Nevertheless, both will lead to reduction of CO2. It has been estimated that EEXI will cause something less than 5% reduction. CII is expected to affect higher reduction. Will depend on what measures are taken for each vessel.
Thank you, John. Stella, your thoughts?
Yes, I may say that what Mr. Kokarakis shared with us earlier is reflected also to the proposals in the next MEPC for the agenda. The majority of the proposals are regarding the CII. They focused on this measure. Nevertheless, we need to, we still have things to clarify for the EEXI, for example, for the definition of the reference speed. And we hope that this will be clarified in the next MEPC.
Stella, thank you. Oh, sorry, apologies. Please, go on, Stella.
No, it's okay if you want to ask me something.
No, I would like to just quickly comment. I've been in shipping approximately 30 years now, and I'm tired of hearing that there's a number of issues, complex, uncertain, and that will have to be sorted out in the next MEPC, in the next, MSC, and so on and so forth. This will never stop. This is one of the certainties I have being 30 years in the industry. Please go on.
Well, actually, this is a challenge also, having the regulations and not the guidelines and the, let's say, detailed direction, enhancing the uncertainty mentioned before. So, unfortunately, it is what it is. We don't have clear guidelines for some topics for the EEXI and the CII. And we need to be alerted and have our eyes open to be always updated on these topics, at least until the next measure of the IMO greenhouse gas strategy. Yes.
Okay. There's a wise man once said, there's always a gift in every challenge. I would like to challenge you, let's say, to find the gift in all these, challenges posed regulatory-wise. I mean, that goes to all of us across the industry. Panos, your thoughts, because you have to face these challenges, you have to solve them.
You open big discussions actually now. Obviously, we don't. We need time to discuss this one. What has to be understood is what Mr. Kokarakis said before. CII is operational measure, meaning that what CII defines is when you have a voyage from Shanghai to Los Angeles, if you burn 1,000 tons of fuel, you will be, for instance, C in the rating. 900 tons, you will be B. Less than 800 tons, you will be A. So if you can choose actually how much fuel you will, something that we do already today, how much fuel you will burn for this voyage. When the fuel price is high, we implement low speed and you burn very few fuel. So you are A. When the charter rate is high and the fuel is low, then you burn more fuel and you are C, D, or E. Every ship can be in any category, and it is an operational decision whether it will burn 1,000 tons or will burn 500 or 800. The difference is huge between the speed of 9 knots and the speed of 15 knots. Could be 3 times more. So under this, EEXI probably has no meaning, because if you burn if you have a limit and you burn a certain quantity of fuel for a certain voyage, then why some ships will have also power limitation? What is the point if no ship will burn more than this cap of the fuel? So I think that in the future, of course, there is a different scope, because without EEXI, you don't have the progress of the ship. You don't have the different rating of the ship. You don't have the different standards of the ship in the market. So both have their role in this regulatory environment.
Panos, your thoughts, what are your expectations in terms of savings that you expect to see specifically with EEXI and CII? Your thoughts?
EEXI, probably the savings, but now will be much more severe than what expected. Initially, they expect something like 2% saving. Now, as Mr. Kokarakis said, could be 3 or 4% saving, because we have only few ships which EEXI is implemented. Other ships can speed up. It is a market that will dictate. With CII, as it is today, which depends without penalties and without a proper application, it depends on the charterers and the owners how much will apply and which rating will give. Also, could be relaxed standards, but I think at a certain point that will be a must. I don't think that in 5 or 10 years you will have all ships, as we have seen in some presentations, be C, D, or E and burning the same amount of fuel that they were burned. I think that the regulation will be respected as other regulations have been respected, and it will be also a mechanism that will implement the regulation, and the results will be, could be, of course, as per targets, something like 10% within the next 10 years or even more, because we're talking about a reduction of 2%. After the first 5 years will be a reduction of 2% per year, which sounds minor if you take it per year, but if you take it in the long term of 10 years, then makes a big difference.
Yeah, it could be extremely significant, absolutely. Miltos, your thoughts, key considerations on EEXI and CII?
Okay, one of my first thoughts is the cost of compliance. And of course, the ship owner, as at the first stage, will burden that. Let's assume that the technology is there or the solution is there together with an EPL or a SAPOLI, together with some energy saving technologies, etc. I mean, for a ship being built today, or for most of the majority of ships, existing ships, you will be able to comply for the life cycle of the vessel as the regulations are today. But the cost is a challenge, and of course, a ship owner will want an incentive and a payback. I find this quite difficult at this stage.
Any other thoughts? I mean, I would like to add on the cost of compliance. Just a quick comment. On an annual basis, shipping uses approximately 300 million tons of fuel. Let's assume, for example, that the cost, let's say, to decarbonize the industry, let's assume for the moment, it could be in the range of $500 per ton. Let's assume, because there are studies and thoughts talking about more than $1,000 per ton. That gives us a cost, approximate cost of 150 billion per annum. So I fully agree with what you said. No one is talking about the cost. We've seen very few owners, Ghosh Prokopiou is one of them, who are extremely vibrant and vivid, let's say, and very vocal about the cost. We have, as an industry, have to sort this out at some point. But fully agree, no one is talking about the cost. The costs are extreme, and no one is addressing the topic, because at the end of the day, it has to be, an exercise that makes sense for all the stakeholders. Edmund, yes. Yes.
Yeah, thank you. And sorry, I wasn't sure if you were taking in turn here, but I just, your point about cost of compliance is true, and it's very true. But I think we're slightly missing the point here, and the point is that this is not supposed to be business as usual now. We're in the middle of a transition, an energy transition, and the short-term measures are exactly that. The EEXI and the CII are designed to be short-term measures. And if you think about it, we're talking about ships entering the market from 2030 that are going to have zero carbon fuels. If they've got zero carbon fuels, these measures are irrelevant. I mean, and there will be legislation made that those types of ships will be exempt from these requirements because they won't be applied to them. So we have to think longer term here. And frankly, whilst yes, there are problems, and I take on point all the points made about these measures, the difficulties of applying them, the issues about the lack of guidelines and guidance. But, there's a challenge being thrown down to this industry by the wider society that it has to address, and it has to come up to address those challenges. And these are just part of those problems. I mean, frankly, we all raise the challenges at the beginning, but this is not going to go away. And I think we have to recognize that this is a transition. And these measures, frankly, are going to help us transition, because what they will do will improve the energy efficiency of the sector. They're not designed to be the end goal, though, and I think people need to keep that in mind. Thank you.
Yeah, absolutely. Mark, yes.
Okay, thank you. Yeah, I mean, basically, echo what's been said earlier on. EEXI is more of a filter. It's more, ship owners should be ready to go through that filter as we approach 2023. CII is more of a holistic approach, looking at the entirety of the operations, not only from the ship owner side, but from the charterer side. And that's why it's important to have a good relations and suitable charter party contracts as well between owners and charterers, because charterers will be looking at things such as port optimization, and owners as well, voyage optimization, just-in-time shipping, smart vessels, more weather routing. Then we go back to hull coatings and efficiencies and trim optimizations. But one of the other challenges that I see, and we've discussed this in the panel already, is that not one method fits all. We have different methods applying to everybody. And we're seeing a lot of ship owners who have tonnage coming to the end of their life cycle, who are opting for power limitation, engine power limitation, and that is recognized as a method to get to the EEXI compliance. But then if you look at, for example, the right ship GHG rating, I'm led to believe, and I'm not saying this is right or wrong, I'm just giving my viewpoint on it, that the right ship GHG rating doesn't actually allow for engine power limitation devices, and it takes into consideration other devices such as air lubrication or other devices. So it's very different across all these different platforms and all these monitoring platforms, and that in itself is going to create even more challenges. Thank you.
Yeah, absolutely. John?
I would like to, in continuation of the very correct point by Edmund, I would like to remind everybody that one step at a time. We are still in the short-term measures. We have the mid-term, which is the market-based, for example, and the long-term, which is the more radical alternative fuel changes. I would say more challenging for me in the short terms, given the limited time that IMO has devoted to their deliberation and more time spent by the corresponding groups, I would say that higher challenge is the realistic definition of the key performance indicators. And one of them is the CII, which is actually unrealistic because it promotes the ballast trips. You get credit for a ballast trip, but yet the benefit to the society is practically minimal. So we should think of improving these indices if that's important.
Talking about improving, I would like to also ask other members of the panel if they have any ideas of how we should, let's say, the direction we should look towards improving the CII specifically, because EEXI, as you all correctly pointed out, that's a one-off measure. How about improving the CII and all these operational measures? Where is the direction we should look towards in the near future? Panos, Edmund, any thoughts you may have? Panos?
Yeah, John Kokarakis is right. The CII is calculated as air without considering the cargo, and we know that laden ship has completely different consumption than a ballast ship. However, other organizations, the charters, Sea Cargo Charter Initiative, Poseidon Principles, and RightShip, and in general, charterers are considering the cargo and are calculating the CII as EOI with the cargo inside. Probably also IMO later on will consider the same. Regarding the cost, which is a very important aspect, and I would like to talk about this, the cost going to have quite different impact in each country, and very severe impact in a country which try to be developed. As you understand that some products will be actually prohibited, new routes may be discovered, and the new markets will be discovered, will be an upheaval. We have to see, and that's why we have steps, we have to see how will be the reaction of the global development and the global economy. And because actually the development of the world, it was based on the very cheap transportation that shipping was offering up to now. Changing this parameter, we're going to have a great geopolitical impact. And then we have to see whether we will proceed as planned, and whether we will accelerate or take some other measures by the time that we will have the infrastructure and the new fuels ready, that probably would reduce the cost.
Yeah, absolutely, absolutely, Panos. And at some point, we're talking about, fully agree about the comment about the global economy, and we are talking about the economy as being something static, and in fact, it is dynamic. And it's not only dynamic, but also affected by the so-called black swan events, like the 9/11 incident in the US, like the COVID, pandemic, like the Russian-Ukrainian conflict, and so on and so forth. It's never ending. Fully agree, and we have to be a little bit realistic about it. Edmund, you would like to comment? You have to
unmute. Sorry, apologies. Thank you. And yes, indeed, and I concur with what Panos said about the EOI. I mean, that is a guideline that's been around actually since 2009, and in that calculation, the cargo carried is used. But of course, the difficulty of that is it then potentially penalises those ships and the ship types that deploy or require extensive ballast voyages, and that is part of their trade. That is part of their work, if you like, because they won't necessarily always be carrying cargo. So it is this debate about what is the value ultimately to society of the individual ship and the cargo it carries. And so that it will carry on that discussion going forward. And we've already seen, I mean, the correspondence group that is reporting into MEPC 78 have issued an extensive report, including correction factors for various ship types. And we may have to see that further developed as we go forward. But it is this whole point about the value of the industry to society, and it's critical to us, to how the policymakers, the decision makers will view the shipping sector, and how it will view how it should place additional burdens on the sector to achieve the climate goals, which are equally critical. So as I said, it's not an easy answer, I'm afraid.
Okay, Mark, John, I would like to ask for your patience. Mark would like to comment.
Yes, yeah. I mean, it was just following on from what Edmund said there, really, and the correction factors are, I mean, we've had it brought to our attention, for example, tankers, you know, who spend long time discharging cargo, burning fuel while they cover no distance. So that means the correction factors are needed to that they're accurately monitored. But I think with all of this, I think we're always going to find potential flaws in any avenue we go down. But the grand aim here is to basically decarbonize as much as possible. And these measures are trying to do that, although they are very complicated, and it is going to take a long period of time to get them settled down and moving in the right direction. But it's just something worth considering that that there is going to be potential flaws in whichever system, whether it's the EEUI or the AER or whichever system you use, whichever type of ship you're operating, there's going to be different viewpoints as to the system that's used. That's just what I want to say on that. Thank you.
Yeah, absolutely, Mark. John.
We can talk about the correction factors at length because it's an interesting point, but I would like to go back to the improvement of CII, and EOI is probably the more realistic way to judge and assess the effectiveness, the efficiency of a vessel. Unfortunately, the sea is continuously changing. It's variable by itself, inherently varying. We have parameters that change continuously. So there is no convergence at EOI, and neither there is convergence the CII. So one solution is to follow the so-called mutual funds approach. That is to follow the Danish proposal. Denmark proposed to consider the whole fleet or pools of fleets. This will probably, similarly to a mutual fund, will kind of make more robust the definition of CII and reduce the variability. Otherwise, we are doomed to abandon even CII in its today's form. Time will show.
Absolutely, absolutely. But I am afraid that the industry is a little bit reluctant, speaking in general terms, in taking proper decisions given the tight time frames, because as Edmund correctly pointed out, we are thrown some challenges by the greater society here, and we have to respond as an industry. And I fully understand all these complexities, among other things. Any thoughts, Stella and Miltos, you may have on towards the direction we should be looking in improving CII, if you have any thoughts? No? That's okay. Stella, yes.
Okay, let me just a comment. I think that a sophisticated software helping ship managers doing the monitoring on a voyage basis so that they can plan in the future and using the systems with predictions on their CII rating, this might help to remain within the desirable limits, ABC or C rating.
Okay. Milton, comment, yes.
Yes, I fully agree with Stella that, let's say, digitalization will certainly be a way to help the CII, especially since I believe that CII, being an operational measure and having to be calculated on an annual basis, nevertheless, I think it has to be calculated per voyage and added up to see at the end of the year what will the rating be, in order to maybe take some corrective actions towards the end of the closing year. This is tricky because we don't know how it will position the vessel on the charterer. This is another consideration of mine towards CII.
Okay, Edmund, yes.
Yes, thank you again, and apologies for coming back. But I think it's just to pick up on the point about the CII. I think what we're beginning to see in general is that the CII is going to be factored into decisions made by charterers. It's going to be considered certainly by the financiers. But But also, we've also seen it now being included as part of a sort of proposal made by China to the intersessional meeting next month, or very soon at the IMO, for a sort of hybrid market-based measure, if you like, where the CII would form the basis of a sort of a reward scheme where higher performing vessels are given a reward, and obviously to incentivize those vessels into the market. So I think the CII, John's point about the CII potentially being removed because it doesn't seem to be seen to be work, I doubt that. I think it will just be sort of morphed into potentially other provisions and other uses, and certainly the market will use it. And I think for that reason, it won't necessarily disappear readily in the near term. So thank you.
Okay. Now, my next topic would be the EU legislations. We have the Fit for 55 legislative package proposed back in July 2021. We have the EU Trading Systems Directive, the Fuel EU Maritime Regulation, the Alternative Fuels Infrastructure Regulation. We have the Energy Taxation Directive, a lot of legislative work. And that was before the Russian-Ukrainian conflict. And I would like to ask you, what are your key considerations with respect to the EU legislation? And of course, if you let's say, share the concerns about the delaying taking final decisions due to the Russian-Ukrainian conflict, because the EU now is in a difficult spot, and I'm not sure that this is a key priority issue for the time being. What are your thoughts with respect to the EU greenhouse gas legislation? John, your thoughts?
I would like to point out that in contrast to the MRV regulation, which actually was moving very fast, I see that the Fit for 55 and the ETS market-based measure do not go in the same pace. I see that there is a delay. There are many things that remain, they are not announced, they are not discussed. I'm not aware of stakeholders meeting in Brussels like the ESSF groups in the MRV case to clarify a few things. Like, for example, we don't know the reference carbon intensity in the Fuel EU Maritime, which is one way of taxation. We don't know what are going to be the allowances in the ETS scheme, and we see the carbon tax going up all the time. So high uncertainty is one way, and the second is darkness in the definition of the limits of what is going to be the boundary, after which we pay a lot of penalties which are going to mount and mount and mount and exceed the OPEX of the vessel. I'm very concerned about these costs imposed by EU Fit for 55.
Stella, your thoughts?
Personally, I'm afraid if the Fuel EU Maritime Regulation will overlap some of the EU ETS. I think this needs more clarification from the European Commission. This is my biggest concern, the overlapping, and the future is not clear for this. The only certain thing is that ship owners will simply have to pay to emit carbon dioxide. This is clear. To this scope, probably if they have to pay on carbon taxes or if they have to pay to emit CO2, it's better to invest in new technologies aiming for the decarbonization. If they have to choose one of these two.
It's easier. This is always easier said than done, and I'm sure that the industry leaders, let's say the Maersk and the MSCs of this world, who have, let's say, the biggest wallets for the time being, due to the booming market in the container sector, they do have, let's say now, the financial, let's say, element properly addressed. And I'm not talking about, for example, Panos, company, because Panos company is managing more than 50, more or less, ships. I'm talking about the smaller operators, those who operate, let's say, 5 or 10 ships. How about these operators? How competitive they will be in this market? So I'm sure that it's easier said than done. I cannot disagree. I fully agree with what you said, but there's also a challenge. And we haven't seen these smaller ship operators and managers having their voice properly, addressed across the industry. Panos, your thoughts on the greenhouse gas, the EU greenhouse gas regulations, your concerns?
I think that it will be better to have only IMO. That's something that we have already discussed. So anyway, the local authorities are moving forward with their own regulations. So now we have ETS and we have the EU, Fuel EU. Regarding ETS, it's an environmental regulation, but we don't know what are the environmental targets and what we are expecting from this environmental regulation. We only know how much we're going to pay. Even that, it is something that it is to be decided later on. And every year we're going to have something different taxation to pay. But even 2 years ago, when DELF had for the European Union a study, ETS was not one of the proposed measures. However, EU went for that measure that they have a clear financial impact rather than environmental impact. Regarding Fuel EU, there are a number of complications. Mr. Kokarakis already mentioned a few. The fact, for instance, that it is correct to calculate the emissions from well to wake. However, the ship cannot be responsible for the emissions from well to tank. So it is very difficult to calculate, to be responsible for emissions that were done before the delivery on board. And I don't think that the owners, the manager, will have any power actually to reduce this type of emissions.
Absolutely. Miltos, your concern?
First of all, I fully agree with all the points made from the previous speakers. I think it's also very important and vital for the industry that it's clearly clarified how these EU measures and all the amounts that will be collected from ETS and all that will be returned back to finance green projects. And because early movers to comply with all these regulations will take a big financial burden, and somehow they need to have an incentive. I mean, we saw recently Japan proposing something similar, that early movers adopting new technologies should be somehow compensated from these funds in order to move forward and slowly go to the measures that go to the era that these measures will not be needed in the future, because that's the ultimate goal, to take down greenhouse gas emissions globally. Thank you.
Okay. Mark?
Okay, thank you. I have mixed thoughts on EU ETS, to be honest, which I'm sure is not, it's only me who thinks that. We have a danger, of course, that as we head into this EU ETS period, the data reporting which ships make now, any errors in that don't really cost them as much as they would do as we go through the EU ETS. When they start getting, we've had information back from verifiers, for example, which state that, a fleet of ships, 2 different ships are reporting completely different CO2 emissions. And that really needs to be fine-tuned so that the correct data is reported if we do move into this EU ETS phase. That's just one thing to consider. Also as well, ships that are going to be bunkering around the world to trade to the EU zone, then they need to prove that the fuel they've bunkered is compliant. And as we've discussed before, there's the well to well-to-tank analysis and furthermore the well-to-wake analysis. So that's something else which complicates things. The only other thing I would like to say though is that the EU are sometimes early movers with things like this. I believe the Fuel EU Maritime, for example, is being looked at by the IMO for more of a global basis. So there probably are some good ideas to pull from that. And things like carbon capture, for example. The EU ETS has built up a little bit of experience and background with the shoreside industries. So perhaps some of the information, some of the ideas, things like carbon capture, which I believe the EU ETS allow for, and presently the IMO don't, or some of these ideas will be useful and will come into the forefront with other areas and other global and IMO initiatives and regulations.
Yeah.
Thank you.
Thank you for pointing out this carbon capture. I fully agree on the carbon capture. It could be producing a number of innovative, let's say, thoughts in the near future. Edmund, your thoughts?
Thank you. And yeah, and several of the previous speakers have raised very valid points. And I think, you know, that the whole Fit for 55 package is a very, the inclusion of shipping in that is a very noble attempt to try and address the real conundrum of supply and demand. And try and build policy instruments that can actually address those particular challenges for the sector. I mean, I prepared a report some 2 years ago for the International Chamber of Shipping and the European Community of Shipowners Association on the inclusion of shipping in the EU ETS. And one of the big issues I raised in that is carbon leakage when I prepared that report. And I still, frankly, at the time, it was sort of, there was some sort of counter briefing made and it's sort of slightly dismissed as being not going to be valid. But I saw recently that a report by CE Delft actually highlighted the real concerns with carbon leakage. And those problems, that's just another example of where if you don't have global regulation for a global sector like shipping, you know, you end up with problems and challenges of implementation. And I still have yet to see how that particular risk, which I think is significant, is going to be addressed by these instruments. And as I said, there are other issues. I say it's a noble attempt, but I agree with Mark about the fuel standard as well. I think that is something that's been taken on by the IMO, and others are you know, falling in behind that idea. But I still think regional regulation, it has significant problems for a sector like shipping, and whether it will be, those concerns will be enough to see the fundamental redesign of the instruments. I doubt it. Saying that, my doubt is slightly wavering since the February this year and what's happened with Ukraine and Russia, because that is now fundamentally challenging the whole energy policy of the European Union. So there are some big factors at play here, and really, it's very difficult to identify exactly what will happen. But for me, there are still some fundamental flaws which really haven't seen how they've been addressed. Thank you.
I would like to go back to what Mark pointed out in his initial opening comment about the 3 C's, and one of these 3 C's has been collaboration. And it seems that we are looking for, you know, different types of stakeholders not properly collaborating because there are a number of issues not properly addressed. I would like to ask your thoughts towards how we could, let's say, improve or streamline or avoid, because there's a number of regional, there's a divergence. Instead of convergence, there's a divergence between international legislations. That should be IMO, as Panos correctly pointed out. But we've seen local legislation applied out of the blue, or not so out of the blue, but it is actually out of the blue. There is no, you know, consensus development phases, no discussion with the stakeholders. At some point, there are local stakeholders. It could be in the EU, it could be in USA, it could be in Korea, in China, in several other locations, and so on and so forth. What are your thoughts? How could we improve collaboration, and how could we, let's say, streamline this decision-making process? Edmund, your thoughts?
Yeah, I'm sorry to dive in on this, but I think this is fundamentally very important. And in fact, this is one of the very positive initiatives that's happened over the last few months, and that is the Green Corridor Some disagree. I know there are some people disagreeing about it, but I actually think this is a real way of getting over this problem of chicken and egg. It identifies essentially two nodes, at least two nodes in the value chain for shipping, and it makes sure those nodes are connected in terms of the fuel and the energy that's going to be supplied to ships. And I think, you know, what you can do around the end of each of the nodes, i.e. the ports, is you can build sort of energy hubs. And we talked about that earlier. That point was made earlier about, I think in the previous panel, there was a presentation made by Professor Lyridis, which was, I think, was very interesting. And you know, you can build a hub around each port, which is based on energy, and it's to do with linking not just the shipping sector, but also to other sectors using those energy sources, but also the connectivity with the network supplying those energy sources. So, for example, if it's going to be hydrogen, you need to have the right terminal, whether it's liquid or gas, and it's likely to be liquid if it's going to be using hydrogen. So you need liquefaction. So building that sort of framework, if you like, that ecosystem away from the port, but also connecting into the port, to the green corridor between other ports, I think is a really fantastic, actually, and a positive move forward. And you talk about collaboration, and this is where we're seeing enormous collaboration building from that. So as I said, I think that's a real positive in the recent times. Thank you.
Okay, John?
I believe I will go with Panos' idea to focus on IMO. I believe IMO is the central instrument to define the potential collaboration, the central instrument to define market-based measures, unifying everybody. Otherwise, we are going to have China ETS, USA ETS, and so on. So let's not forget, people blame IMO for being slow. Okay, let's not forget that IMO, the last 3 or 4 MEPCs, has proceedings with a total time of 15 hours, replacing the usual 5-day proceedings. So what can you do in 15 hours? If 1 or 2 countries want to disrupt the proceedings, they can do it and nothing comes out. It has happened before, and hopefully it will not happen this coming June, where we expect a lot of things to be finalized and adopted. And one of them is actually the market-based measures are going to be discussed next year, the mid-term measures, but we still see IMO as the unifying organ that will coordinate everybody.
The point is, John, I would like to hear your thoughts about it, how you incentivize all the other stakeholders to stay clear, to stay in their lane, let's say, and let IMO do the job. Because I have to remind all our viewers and all our panelists here, EU said you have to act on this, otherwise I will enforce this. And EU was not satisfied, in brackets, with what IMO has decided, and then said, yes, we will proceed with the UMRV, then we'll proceed with this, and so on and so forth. And we have to remind ourselves, it was back with Mitropoulos. I think it was the last action by Thymio before leaving IMO. This was back in 2013, I think, if I recall correctly, with the legislation concerning the ship energy.
The EDI.
Yeah, no, it was the SEMP. The same
okay.
Before that. I mean, and that was taken as a consensus, let's say, measure before someone else was throwing something in shipping. How we incentivize these stakeholders to stay clear, let's say, out of IMO work? Because IMO, and I agree with that for a number of reasons, is a little bit slow, because there should be consensus built, absolutely. But how do we, as an industry, as stakeholders with industry, incentivize these local stakeholders? Because there's always a challenge of, let's say, letting them, take the action in their hands.
Remind everybody that shipping moves 90% of world trade.
It doesn't. Sorry, John. It doesn't. That argument is not going to be supported for any longer. It's seen, shipping is just seen as part of a logistic. It's a logistics part of the movement of goods around the world, and the people who are demanding lower carbon footprint for those goods, and those are saying actually shipping has to be part of this chain. We are demanding that. It's not the government. It's the
we are going that direction, but of course, Rome was not built in one day. We have to remember that.
But I'd also remind everyone, Apostolos, your point about the EEDI and the SEMP. I mean, I was there when it was adopted, and it wasn't adopted by consensus. It was adopted by a vote. Uniquely, not uniquely, but rarely at IMO, we had a vote because some governments, some parties to Annex 6 said no, they didn't want to adopt it, but others were just, had run out of patience. And that may be the case. And going back to the point about fractioning and having different market-based measures around the world, I think that is a real, frankly, that is a real risk. And I think to get consensus on a market-based measure at IMO is going to be an enormous challenge.
It's not going to be.
At the moment, there's people who advocate ETS, there's people who advocate levy. And within each group of those, there's people who disagree on how that should be applied. And then there's others who actually don't want anything at all. So you've almost got three groups of IMO, and that's partly why the discussion goes around in circles to a degree. But I don't get me wrong. Everyone knows. I mean, I'm an ex-IMO official. I support the IMO and its goals, and I think it is the right place to make regulation for international shipping. But it's problematic because these instruments, particularly market-based measures, they step on lots of toes, not just shipping, but economies and trade and societies, and you see that in the discussion about impacts on states. So I think it is very complex. But I as I said, I fear that MBMs might become a bridge too far for IMO.
This is why we have the voting process.
Absolutely, but John, we have to remind ourselves this is an ongoing discussion on an international level for more than 10 years now. And there's no sort of consensus in the horizon. So, and we also have to. I mean, a couple of years ago, we haven't heard that, let's say, large retailers like Amazon, like large chains, stating that by 2040, now they're giving numbers. They would, let's say, request shippers to use zero carbon fuels on board the ships that will be carrying these goods across the sea. We haven't heard, stuff
They're
like
not going to wait. They're not going to wait.
Yeah, so they're not going to wait. Mark, your thoughts?
Yeah, I mean, on the subject of collaboration, there's so many areas of collaboration which need to be considered as we move forward into this next period. I mean, if we just look around the virtual room now, we've got class societies, regulatory bodies, P&I clubs. That to me is a sign of good collaboration. And I think we need a lot more of that as we move forward to this next bit. That's very important, sharing information. Something we've actually done and we're launching next week is we're allowing our members to share their decarbonization stories, and you'll be surprised how much information they want to share with other ship owners. And we are familiar with the competition between various ship owners, but we do also believe that it's very useful to share information on this as we move through this next phase. That's not as easy as we wish, obviously, of course, and there is going to be the competitive advantage there, but it's just important to share this information as much as possible. And platforms like this are great at doing so. Written platforms, text and documentation, very important to share. Anyway, thank you.
Absolutely, Mark, fully agree. Panos, your thoughts on how should we, let's say, tackle this issue of, let's say, divergence between these stakeholders, and how could we enforce the role of the IMO?
Look, it is clear. You said before that the decarbonization will take a few billions every year, and the total cost is something over almost 3 trillions. So with these kind of figures, we understand that the interest for the decarbonization is coming from all parties, for industries outside shipping. And of course, there are also opportunistic approach for this transition, actually. Then it's obvious that you will have different opinions, and obvious that we have environmental regulations that actually are upsetting the environmentalists. They have no environmental impact at all, or they have also, for instance, replacing the fleet of today with the same technology ships. It's something that will upset upset the environmentalists because we'll have only the negative impact of scrapping useful tonnage. So it is quite difficult actually to find an agreement between all parties here. Things is that the road is very long. We can consider that we need 20 years. We have already 20 years passed since we had LNG as a fuel, and we don't have the LNG availability in all ports. So still now we don't know which will be the fuel of the future. Will be hydrogen, probably, will be ammonia, could be. But anyway, still we have not decided, and we haven't started building ships yet. I mean, massive building of ships. And we are still investigating measures, and we exchange thoughts, but there is a long way until we have this infrastructure. And it will be always a problem to protect environment and shipping industry from these opportunistic approaches from other industries.
Yeah, absolutely. Absolutely. Stella, any thoughts?
I think that shipping should be aligned with the energy production. As correctly mentioned, for example, if we select to burn ammonia, but we cannot bunker ammonia, this is not a clever solution, let's say. However, for the long run, I can see that there are three major low carbon energy technologies. We can achieve our goals with burning fossil fuels actually, but with carbon capture systems. The second one is the nuclear power. Okay, this is it sounds a little bit scary, but it is a technology that we already know that can apply in large scale, and renewable technologies. So for the shipping industry, we need the collaboration also of the other industries. It's not only between us.
Okay, Miltos, your thoughts?
Yes, exactly as Stella said. I mean, collaboration of stakeholders is not only amongst the shipping industry, and I agree with Mr. Kourkoudis and Mr. Kokkarakis that ideally it should be orchestrated by one regulatory body, and this should be IMO, who would then ideally collaborate with stakeholders of other industries to achieve the common goals, to move towards common solutions for shipping, for example. Ideally, we would like to continue in the same way we're working till today, one fuel for all vessels, whatever that would be, and keep shipping sustainable, apart from only looking at the environment. It's important. We need that trade, we need the maritime sector.
Okay. Now, we will be running out of time. We have a few minutes. I would like to ask you to recap your thoughts, and I would like to ask you to give me your wish list on how we should move forward as an industry to decarbonize, let's say. Just, you may recap your thoughts or give a wish list. I would prefer to have the wish list for the near future. You can wish everything, including, among other things, low costs, full collaboration, and so on and so forth. Things that cannot happen in real life because the challenges are vast. The cost is an issue. The collaboration is an issue. The compliance standards, the consensus across the industry, different types of stakeholders having different priorities. And as Panos correctly pointed out, we're talking about trillions of dollars here. And there is always an opportunistic push across the industry for a number of reasons. So your thoughts, let's say, to recap, the wish list to decarbonize, if you can give it to me in less than, let's say, approximately 60 seconds, that would be fine. John.
I would say that the future is going to be multi-fuel, as everybody says, but we should avoid chasing our tails, because we should focus on specific solutions and not going after, I mean, splitting our resources in many different solutions. I believe that it's impossible to achieve that, but nevertheless, focus is necessary. And probably it was mentioned here that carbon capture could be a very nice solution. I would like to see it applied on board the vessel because it will save us from changing what we burn today. We can still continue burning what we do now and still have a cleaner atmosphere. So focus on a few promising technologies is my wish list.
Okay. Stella, your thoughts, your wish list.
My wish list is to have funds that will solve the problem of the cost and will give the opportunity to for the research and development to develop new low carbon solutions. And of course, I can see that, or I wish at least that carbon capture will either pre-combustion or post-combustion will be in the market for the next years, because we think of carbon dioxide as an enemy, but we should change the way of thinking. We can use carbon dioxide to develop something else. If we change our point of view, like making carbon a trading commodity to develop products or whatever, I think this could be a nice solution, at least for up to 2050.
Okay. Panos, your thoughts?
Regarding technologies and the way forward, I haven't made up my mind, and I can't tell you that this is the correct way to go forward. I think it is still too early to bet on one of the technologies that are available. But I know that the way to decarbonization is a challenge, and it is economical, technical, and environmental challenge. There are different interests. It will be a battle. And of course, we're going to have winners and losers in this battle. Someone will pay more, someone will gain from this battle. And I wish that at least the environment will be among the winners at the end.
Okay. Miltos, your thoughts?
My thoughts continue with Mr. Kokarakis and Stella said on the carbon capture, because I do believe this is the realistic approach for the time being. It's a technology which is almost available, I will put it like that. It will be easy to handle, it will not have any difficulty for crew handling, and it will give a direct solution. And it's very important that it can be combined with other technologies which also exist today. I mean, LNG and carbon capture is one solution that we know it could work. LNG is available. It has been working for a big number of vessels right now. We have energy-saving technologies. We even have the most exotic ones, such as wind. So I think my wish list is to look at the realistic approach, and I think we can make steps forward.
Thank you. Mark?
Thanks. Yeah, I was sorry to use another word beginning with C, but I'd like to use the word clarity. And that's really what I'd like to see as we move forward into this next bit, a little bit more clarity, so that everybody understands we're all going in the same direction, all the regulatory bodies are pushing in the same way. Collaboration, again, I'm going to mention, but I think it was touched on before in the last part of the discussion, collaboration between shore and sea going as well. You know, for example, hydrogen at the minute, green hydrogen, the production costs are quite high, but as it's used more and more on the shore side part of the industry, we see the costs come down within the next decade to similar costs of non-renewable hydrogen. So we need that input into shipping as well. It's not just shipping alone. Understanding and consideration to all of that tonnage, as we touched on earlier there, you know, it's not one size fits all here. It's very complicated. And one thing I just really want to bring forward is if we look back at IMO 2020, it was a very simple decision for ship owners, really. either use distillates or, VLSFO, or you fit an exhaust gas cleaning system. Some of the bigger shipping companies had the advantage of being able to split their fleet, half with scrubbers and half without, and they gained from this obviously through the times where it's moved up and down. But we need to think of the smaller shipping companies throughout all this, and we need to protect them as well. It's not just the big companies. We need to think of everybody else. And that's where common research comes in, and a research fund perhaps to protect that. And then just on my last point, carbon capture, it's been mentioned a few times, big believer in it myself and how it moves forward. But also carbon capture has been emphasized for enhanced oil recovery and other shoreside techniques. So perhaps we should look at that capturing the carbon and using it for other methods and to assist other systems and products throughout not just the shipping industry, but elsewhere. And with that, I'd just like to say thank you.
Thank you. Edmund.
Yes, thank you very much. And picking up on pretty much, I think all the other panelists have said and mentioned technology, and I think, what we need to see is improvements in technology readiness levels with all these technologies that have been proposed. And one way of course, doing that is for the MEPC next month or in June to approve for circulation the amendments for the R&D fund that's been proposed by several governments and the industry as a whole. So that would again a clear sign from the IMO as the global regulator, leadership that is needed to say, look, we are leading this sector to improve and understand the technologies that we need to deploy to help us decarbonize, because we do need to do that, and that would support all those small ship owners as well, because it's not just the big guys who can afford to go and do their own research. The other thing I would also, as you said on my wish list, is and Stella mentioned nuclear and the fact it's scary. Well, I mean, for me, what is scary are the impacts of climate change, which frankly, as the IPCC have just recently reported, are significant and growing. And really, we have to take a step back from what we perceive as our risks of technologies and say, well, look, we may have to take on board technologies which we at the moment are necessarily not comfortable with. But when you begin to understand the risk, I mean, the diesel engine produces a lot of emissions that kill a lot of people, and the impact of using hydrocarbons kills a lot of people. Using other technologies, yes, they are risky, but if those risks can be properly and effectively managed, then why not look at them as solutions to this sector? And nuclear, frankly, is potentially that. So again, that's one of the wish lists I would like to see is more emphasis on nuclear power. Thank you.
Okay, thank you very much. I have to say I'm persuaded by what John and Mark pointed out about the carbon capture and storage. I'm sure humanity is going to Mars now. I'm sure the technology will be here for a number of uses. So having said that, I would like to thank you all very much for the vivid discussion we had. And I would like to thank all our viewers. We'll be moving on with sessions on shipping decarbonization and ship recycling before we close the day with awards. Thank you all very much and stay tuned. Thank you.
Thank you very much.
Thank you. Bye-bye.
Thank you very much for inviting me to this forum, and I will be talking about the shipping decarbonization status and prospects. And the purpose of my talk is to take a look at recent developments to decarbonize the shipping, both at the IMO level, specifically the MEPC, Marine Environment Protection Committee, and also at the EU, and also try to assess prospects for the future. And I will attempt also to link to some of the research we are doing here at EDU. As a disclaimer, what I'm going to talk about is not encyclopedic. And much of what I will say can be found in this paper that was published last September, Shipping Decarbonization in the Aftermath of MEPC 76. That was the meeting that happened last June. There was an additional meeting in November, but I will cover that in my talk. And this is an open access paper. So I guess everybody knows about the initial IMO strategy, where the central ambition is to reduce annual greenhouse gas emissions from ships by at least 50% by 2050 versus 2008 levels. There's also an intermediate reduction target of reducing annual CO2 emissions per transport work by at least 40%. And then the target is to try to push this towards 70% by 2050, again versus 2008 levels. However, the trend has been disturbing, and I'm quoting from the latest, the fourth IMO greenhouse gas study, which was published in the summer of 2020. And you can see here that the CO2 equivalent emissions, at least in recent years, have increased something like 10% between 2012 and 2018. And then the question is, what can be done to reverse this trend and let alone reach the greenhouse gas reduction target? And it's clear that some measures need to be taken very urgently. So most of the discussion after the IMO strategy has been focused on the so-called short-term measures. And in fact, last summer, MEPC 76 adopted the so-called combined EEXI SEMP CII measure, where EEXI is an acronym for the Energy Efficiency Existing Ship Index, which is actually the application of EEDI to existing ships. SEMP is the known Ship Energy Efficiency Management Plan. They want to strengthen that. And then CII, I will talk about this in a minute, is the so-called carbon intensity indicator. And then last summer, MEPC 76 adopted a so-called non-linear CII reduction scale of 1% per annum until 2023. 2023 is next year, and then a 2% per annum reduction between 2023 and 2027, and left open what's going to happen after 2026 and until 2030. So there are actually two ways to measure CII. One is the so-called supply-based, and it's based on the annual efficiency ratio, which is defined as the ratio of, for any particular ship, the ratio of CO2 divided by the product of dead weight times the miles that are sailed in a year. And then you have EEOI, which is the so-called demand-based metric, which is the known energy efficiency operational indicator. Again, it is the ratio of CO2. The numerator is the same, but the denominator is the actual ton miles that are carried by the ship. And in order to compute it, you need to know detailed cargo information. What difference does it make? It makes a difference because if you use AER in order to reach the 2030 target, you have to reduce it by 22%. And if you use EEOI, you only need to reduce it by 11%. This is according to the fourth IMO greenhouse gas study. So which of the two metrics has the IMO endorsed? This is an interesting question. And the answer is both. They put both on the table, and the reason is that there was a big disagreement at MEPC 76. There was one group that was pushing for AER, the other for EEOI, and the IMO did not want to displease any of the two groups, so they left both metrics at the table. So what I find amazing here is that some 4 years after the adoption of the initial IMO strategy, the IMO has not decided yet how to measure transport work, and that's one thing. And the second thing is that it's not clear what's going to happen after 2026. If you look at the strategy and the medium-term measures, you will see market-based measures included under the medium-term measures, but only indirectly in the sense that they say possibly including market-based measures. You know, possibly means possibly yes and possibly no. And there has been a history of market-based measures at the IMO. In 2010, even before the EEDI was adopted, there was an expert group formed by the Secretary General I was a member of that group. There was 11 MBM proposals submitted. There was a big report submitted, 300 pages. There was no preference on any MBMs. There were various discussions since then, and the outcome was that in 2013, the discussion was suspended, mainly for political reasons. But then the interesting thing is that last fall, this discussion has reopened. We have an ongoing project at DDU called MBM Sushi for Sustainable Shipping. The PhD student is Sotiria Laguardo, and the funding comes from the Orange Fund, and we have an advisory committee that these important organizations and companies are part of our advisory board. We have produced several papers. If somebody wants to see them, please send me an email. The most recent is a paper that will appear in Transportation Research Part D, which investigates the impacts of a levy for the tanker sector, where we compute how much CO2 can be reduced by an appropriate levy. And there is another one that is also in the pipeline, investigating the implications of the EU ETS on European container routes. And we examine the possibility that transshipment hubs that are not in the EU, but close to the EU, may be established just to avoid paying into the EU ETS. And we examine two cases, Piraeus versus Izmir and Algeciras versus Tanger Med. And so there are some other papers in the pipeline. For example, now we're working on MBMs and alternative fuels. And there was another project that was completed December 2020, which we did for the Danish Maritime Authority, the funding from the Danish Maritime Fund. And there was one paper published in 2021 that performs a comparative evaluation of MBMs. So you see here on the left-hand side the evaluation criteria, greenhouse gas reduction effectiveness, compatibility with existing framework, potential implementation timeline, impacts on states, all those things that you see here on the left-hand side. And the categories of MBMs examined was bunker levy or carbon levy, global ETS versus regional ETS, and other MBM proposals to the IMO and other MBMs. So, I mean, looking first at the levy variants, there was one submitted in 2010 by Denmark, was the leader in that, the so-called International Greenhouse Gas Fund. But then it can be a simple levy on bunker fuel or on CO2 equivalent emissions, or variants that include restrictions on what ships would be subject to the levy, or differentiation of the levy according to some criteria. The simplest form of MBM is a pure levy on bunker fuel or a pure levy on CO2 equivalent emissions. And in fact, there are submissions to the IMO right now by ICS and Intercargo on one hand, and the Marshall Islands and Solomon Islands on the other. I have here the submissions. They have been discussed, but they will be discussed again at the MEPC. Actually, the first submission cites our paper. The second submission, by Marshall Islands and Solomon Islands, they propose a levy of $100 per ton of CO2 equivalent, which is something like $300 per ton of fuel. And then you have the ETS variants, which can be a global ETS. There have been some proposals suggesting a global ETS back in 2010 by Norway, UK, France, and Germany. Separate proposals, but very similar. And then there is the regional ETS, which is what is right now proposed by the European Commission in the context of the EU Fit for 55 package, and there has been a vote in the Parliament. So you probably know that as soon as the new European Commission President Ursula von der Leyen took office, she said, among other things, that she wants shipping into the EU ETS. And in fact, this is in the context of the European Green Deal and the Fit for 55 package. So in July, a few weeks after MEPC 76, they submitted this big proposal, 581 pages for a directive to include shipping into the EU ETS. And in parallel, they submitted the proposal to so-called Fuel EU Maritime, which promotes the development of alternative renewable and low carbon fuels. This paper that I mentioned before performs this comparative evaluation. I don't have the time to go over the details, but we evaluate mainly the levy-based and ETS-based proposals, and we find overall that the levy-based has some advantages over the ETS-based according to this criteria. The way ahead, well, things are very slow. I mean, I'm not really surprised by this. Things are very slow at the IMO. I hope that they pick up some speed, perhaps as a result of the pressure from the European Union. The European Union is moving faster, but things are very uncertain because it depends on the outcome of the negotiation process between the Commission, the Parliament, and the Council. There is no interaction between the two processes. That's what I found very interesting. And there are activities by some industry stakeholders to speed up the process, having some initiatives of their own. So I think the next 2 months will be very interesting. So, I mean, this concludes my paper. We have a large number of papers in this area and in the decarbonization. If anybody is interested, they can send me an email. And there is this book that appeared in 2019. Actually, I'm working now on a sequel of this book, Sustainable Shipping. And this concludes my presentation, and thank you very much.
Good morning, good afternoon, good day. I'm Dallas Smith, the VP of LNG and Alternative Fuels for the Liberian Registry. A little bit about my background. I recently retired from the U.S. Coast Guard, after 20 years of service, where the last 6 years I ran the Coast Guard's Liquefied Gas National Center of Expertise. So for the U.S. Coast Guard, I oversaw all LNG as fuel, LNG bunkering, and LNG carriers. I have a very similar role here with the Liberian Registry, where I lead the global gas team, where we look at designs and approvals of new construction all the way through delivery and operation. A little bit about the Liberian Registry. We have over 5,100 registered vessels, which is 210 million gross tons, which gives us 14% of the world's market share. We also have over 300,000 active seafarers. The state of the liquefied gas industry currently, there are 2,200 liquefied gas carriers currently operating or in various levels of construction. There are 1,500 LPG carriers and about 700 LNG carriers, with another 100 on the order books. There's currently 250 vessels burning LNG worldwide as a fuel. This does not count liquefied gas carriers. And there's an additional 200 gas as fuel vessels on order as well. There's approximately 150 vessels operating that are classified as LNG ready. This doesn't mean the vessels are burning LNG at this time. It means they can do a conversion to burn LNG in the future. In addition, there's over 30 LNG powered cruise ships under construction or currently operating. While I was in the Coast Guard, I was fortunate enough to inspect the first 2 that have been delivered, and look forward to seeing several more in the future. So why are we looking at alternative fuels? It actually started back in mid-2010. IMO and coastal states were looking at a way to improve the emissions around the globe. And it started with the SOx cap reduction, which reduced the amount of sulfur you were allowed to have in your fuel, which recently went from 3.5% to 0.5% in 2020. And even lower in the EEXI zones, which is around the US and parts of Europe, which requires it to be under 0.1%. In addition to the SOx reduction, IMO resolution MEPC 304/72 met, which was IMO's strategy to reduce greenhouse gas emissions. This aligned the IMO with the United Nations Paris Agreement and created the EEDI, and since has created the EEXI requirements. This strategy was to reduce CO2 emissions by at least 40% by 2030 and pushing towards 70% by 2050, with a total annual greenhouse gas reduction of 50% by 2050. Since then, IMO MEPC 76 met, and this is when the IMO adopted the amendments to MARPOL Annex 6. These amendments required all ships to calculate their EEXI from their first annual intermediate survey after January 1st, 2023. In addition, ships over 500 gross tons and above are required to calculate their operational CII rating, which is their carbon intensity indicator rating. They've been collecting data on this since 2018, and starting in 23, ships will have to categorize their energy efficiency from A, B, C, D, or E, where A is the best, and ships that are rated of D or higher, D or E, for 3 consecutive years will be required to submit corrective action plans of how they're going to achieve C or better. Some of the liquefied gas projects that the Liberian Registry has been a part of in the last few years and currently, we delivered the first LNG fueled Alpha-Max tanker, the first vessel approved to burn ethane as a fuel, the first ethane as fuel conversion project. We delivered the largest LNG fueled car carrier in the world and the first LNG fueled Newcastle Max bulk carrier. On the bunkering side, we delivered the Kairos, which is a 7,500 cubic meter LNG bunker vessel with Type C independent tanks, was built in Korea and delivered back in 2019. At the time, it was the largest LNG bunker vessel in the world. Plus, it was the first bunker vessel to bunker in the Baltic Sea. These are a couple photos of our vessels bunkering in U.S. waters. The one on the left is the Sims car carrier. It was the first foreign flagged vessel to bunker LNG in U.S. waters. And then the vessel on the right is our Alpha-Max tanker that was the first to bunker LNG at sea within U.S. waters. Regarding floating LNG, we delivered the Tango FLNG, which is the world's first floating liquefaction platform in the world. It delivers 0.5 MTPAs per year and has 3 Type C independent tanks at 16,000 cubic meters. It was built in China back in 2017 and has been located down in South America, but has recently been shifted over to Europe. So should be seeing it operate again soon. So the upcoming goal is getting to reduce carbon and it potentially go to zero carbon in the future. How are we going to do that? That's a huge question I get very often. I don't have a crystal ball, so I'm not sure exactly what is going to be the future fuel source, but I can tell you our global gas team is working heavily with key stakeholders to help review and approve designs to burn alternative fuels such as liquefied hydrogen, ammonia, methanol, of course, LNG. And some of these new projects where the IGF code came out in 2017. So some of these technologies aren't discussed in the IGF code, but the IGF code gives you the ability to do risk assessments and allow the administration to approve these new fuel sources. And we're doing this through JDPs and JDPs, which are our joint development projects where we work with key stakeholders like the shipyards, the manufacturers, class, the owners, operators, all the involved parties to come up with a design to approve these vessels. Talking about some of the alternative fuels, of course, hydrogen's been a topic for several years now. Hydrogen, of course, is a fuel that everyone's looking at because it does not have a carbon atom and its emissions would be basically water vapor. But some of the issues with hydrogen is storage. It takes about roughly 4 times the amount of storage for hydrogen fuel as it would for traditional fuel sources. So right now it looks like hydrogen is going to be more of a fuel for domestic use, but it's definitely being looked at for more large-scale international use as well. Also, the flammable window with hydrogen is around 4% to 80%, where LNG is 5 to 15%. So this is something else that the flag states are looking at to ensure safety of the crew. Then ammonia, ammonia doesn't have the same storage issues. However, it's toxic and it's, traditional form. So that creates issues for the crew. And then, when they pull the nitrogen from the ammonia to create hydrogen, you have potentially nitrous oxide, which is another greenhouse gas that we're looking at. So again, ammonia is probably going to be a big player in the future, but we're still looking at the best way of handling the actual fuel. Methanol is also a big player. We've already seen several ships delivered using methanol, but methanol has a carbon atom, but it is, substantially lower carbon than, traditional fuel sources, very similar to LNG. So a lot of people are looking at methanol more as a transitional fuel. And then we've done some studies and looked at wind and rotor cells, solar and lithium batteries. Definitely think that this is going to be a player, but it's probably going to be more of a hybrid approach where you're going to use the rotor cells and the batteries more to assist with power. Well, I'm very honored to be speaking with you today. If you have any questions following this conference, please reach out. My email is listed there below. And I look forward to chatting with you. Thank you.
Good day, and thank you for this opportunity to talk about this very interesting topic. Today, we're going to talk about North's approach to decarbonisation as a P&I club and the importance of crew training as an element amongst this. Navigating decarbonisation. This is the area we have formed on North's website to actively discuss these topics as we go throughout this change within the industry. You can see these circles here as they're shown, and that gives some form of description of what happens on the North website and what we do to educate our members. You'll see at the start, number 1, our members asked for technical and contractual guidance. So they approached us at the start and they said, you know, can you help us to understand these new regulations? Can you help us to understand the potential methods to achieve this? And also, as well as the P&I Club, we deal with both owners and charterers. So it's important to understand the contractual complexity and what can be done with charter parties using our in-house legal expertise. So from this, a website was formed called Navigating Decarbonization. You can see the link to that website at the bottom of this page. And that basically is a website which has many different forms of information on it, which we'll talk about next. So if we look at 3 now, the part of the website, we've got articles on alternative fuels, different types of fuels, what you can use, advantages, disadvantages, individual circumstances of each type of fuels, and where they can be used and where they will be used. Technologies, forthcoming regulations, IMO and localized emission targets, such as the EU ETS and the EEXI targets and what that encompasses in 2023, and the carbon intensity indicator, CII, which will be around for a long time moving forward. There's also industry initiatives and more. And to make these articles, we work with classification societies, makers of equipment, experts in their field, and we also use, as we said before, our in-house technical and legal expertise. And this has been really interesting. It's been a really interesting journey for us at North. And what's been most interesting is the welcoming we've received from our members. And we'll go into this more detail later. But as we look at this final point 4, we're really starting to close the circle here, because the members are now coming back to us and they're sharing their decarbonization stories. So that's great. I just want to show you here, this is some of the material that we've got on our website. You can take a picture of this QR code, you can visit the website, and these are just some of the facts and the information that are there, and the challenges on things like engine power limitation, you know, and various other aspects, and LNG is a marine fuel. So you can see all that information is available on our website and easily to access for everybody. You can see here we've got the EU emission trading scheme and carbon trading, and just some descriptions on that and some other items which can help our members understand. The next part of what we did then was we then received a demand from our members for webinars. And what a great time to do it. You know, we ran these remote webinars, and we started off just with one on the basic regulation options, and we brought in classification societies and other experts. So we had a panel of experts, and we answered questions from our members on a live basis, and some of them asked questions before, some of them asked questions afterwards. And then we record these webinars and make them available on our YouTube channel. So far, we've had 6 of these webinars in the series, and they've been viewed by more than 3,000 people. So it's great to see that these webinars are getting viewed and they're leading to the discussions, which is very important. And as we said before, collaboration is the key here. Collaboration across all stakeholders within the industry, but collaboration amongst our members, we're actively encouraging. And we're very happy to say that within the next month, you will see 2 articles written by our members on their different approaches to decarbonisation. One member is using the LNG dual fueled option for their tankers, and another of our members has tried biofuels, a biofuel trial on their vessels. So these are all areas which are great, and it's good that the loop is now getting closed because we're getting the feedback from the sharp end of the business and where it's really happening. That's what we need to see, and we need to hear back from our members so we can share the story across the industry and help our other members in the interests of mutuality. The next part we really want to highlight, and a real concern we've got here, is alternative fuels and crew training challenges. It's important. The IMO, the Maritime Safety Committee, MSC 104, has proposed a new output of comprehensive review and revision of the International Convention on Standards of Training, Certification and Watchkeeping for Seafarers 1978. And this includes the development of training. The current IMO process to start developing training standards, but the concerns are the training standards may only be developed after the adoption of the IMO instruments. In some cases, this may take years, resulting in a misalignment between the date of entry into force of the provisions and the standards and the relevant training standards. So really, it's the first piece in the jigsaw we need to focus on here. We want the industry to think about this. You have cadets coming through training schemes at the moment, and you really need to consider what they're going to be trained in. And because it's not going to be as simple as IMO 2020, when there was a changeover between one type of fuel and another. It's going to be very complicated and multifaceted. So the more you can emphasize on the training as early as possible, then the better. And we're recognizing with the difficulties, one of the difficulties with the crew training is the hands-on experience. You know, we need to give the knowledge, we need to give the theory, we need to bring in the experts, and we need to share this information. But hands-on experience is very useful, and this is quite hard because the vessels, for example, if you look at hydrogen fuel cells or the like, the technology is not there at this moment in time. So whilst we may be able to train the theory, it's very hard to give the hands-on experience. So we need to work with equipment makers, manufacturers and the like to try and get as much knowledge as possible. What we've seen amongst some of our members and other members within the industry, other container carriers, for example, when they brought in LNG as a marine fuel, that they then brought in the top 4 officers, you know, masters, chief engineers, second engineers and chief officers, and they brought them in from the LNG carrier side of the business. So they can then educate all the rest of the crew on LNG bunkering. And that's very good and that's great, and that leads to organic knowledge growth. But as we've just pointed out before, a lot of this technology may not be available. You may not be able to do that. So you may not be able to bring in the masters and the senior officers with experience of fuels such as hydrogen, methanol, ammonia, and some of the other hybrid technologies, because the technology just simply isn't there at the moment. So that's what we're asking everybody to do, to look forward as far as possible, as far in advance, and try and plan this out. Try and plan your training centers, your crew training, your documentation as much as possible. And to assist with this, we're here as a P&I Club, so please feel free for our members to reach out to us, and we'll try and give as much information on this as possible and guide wherever we can. And whatever we can't learn from our in-house experience, we will then reach out to experts and liaising with our members to try and do so and bring the most active information forward. As we've said before, this is a massive challenge within the industry because there's so many different answers here, there's so many different solutions, and it really does depend on trading patterns, vessel types, infrastructure, new regulations, taxing of fuels, you name it. There's just so many different avenues to consider here that we really, really need to be guarded, and we really need to consider this as a very important point. So on to a lighter note now, and we've brought time travel here. You know, we spoke before that it would be great to know more about the future. It really would. If we had a time machine like the DeLorean time machine that we all know from the film Back to the Future, then we could go ahead into the future. We could come back and we could then tailor our training accordingly. We could buy the right vessels. We could do what we want. But we say this in a joking manner, but you know, there was actually some good ideas when this film was developed in 1985, 37 years ago that was. And Dr. Emmett Brown was the brainchild behind this 1.21 gigawatt plutonium flux capacitor, which, you know, is quite a clever piece of machinery. And I'm sure many ships would be happy with that amount of production, power, and capacity. So, but nuclear, we joke on about this being, you know, this is a method of the future. Nuclear molten salt reactors and other small form reactors may form a part of shipping in the very near future. And this is something that is another point that needs to be considered. So it's not just alternative fuels as we know them, but different types of fuels and different types of technologies. Obviously, as a P&I Club, we need to look at the risks, risk assess this, and work with the members and guide them as closely as possible. So that's what else we're there to do. We're there to assess these risks and try and help to manage these risks and reduce any losses and reduce the risk accordingly. So another point we just want to bring here, and really what we've been saying throughout this talk, is that there is a lot of unknown here. It's almost a bit of a roulette wheel, you know. You don't know. You can choose your fuels, but you have to consider them very carefully. And there's just so many different options out there that really it's going to be a big period of choice, a big period of change. What we need to see a lot of is collaboration across the industry. And we as a P&I Club think we can play a big part in that, but we need to work closely with everybody else in the industry. And with that, I just want to say thank you very much and bring this presentation to a close. We look forward to receiving any questions, any contact on anything else on this particular subject. It's been a pleasure. Thank you very much and goodbye.
Good day and a warm welcome to all attendees of this forum. Today, we will discuss about technologies towards decarbonization, focusing more on carbon capture systems. Shipping is facing a big challenge on the journey to 2050 with the ultimate goal to trade with zero emissions. I believe we are all familiar now with existing and upcoming regulations towards this goal. In this challenge, various technologies have been introduced and are being developed. We consider that these solutions are separated in short-term and long-term. Short-term are considered the solutions to reach current targets, or better said, the life cycle of a vessel built today. Long-term, we consider the solutions which will eventually lead to zero emissions. Definitely, as far as short-term solutions are concerned, there is no such thing as one solution fits all, and this, I believe, has been well been understood by now. Nevertheless, a few of these presented today can be applied to the wide majority of shipping. So, as short-term, we can say that energy power limitation or soft power limitations will be the most dominant to tackle the EEXI regulations. Energy-saving technologies, such as hull appendages, can add an assistance, but certainly not be a sole solution. CapEx and payback period are more questionable compared to the energy efficiency gain. Even the more exotic solutions, such as the air lubrication or wind assistance through flattener rotors, have significant CapEx and various considerations to be taken into account for. As far as electrification is concerned, with today's technology, for example, for batteries, for ocean-going vessels, we can only provide an additional power source for port requirements and hotel purposes, but definitely not main power drivers. Alternative marine power solution, or cold ironing, provides a carbon reduction during port stay, and we have seen that it becomes more popular, especially for container vessels these days. Alternative fuels, well, there is a lot of uncertainty here towards availability, safe use, and price. So this brings us to the two options available today. LNG, which is available today, it's a proven technology with existing regulations for safe use, and there is a significant improvement on carbon footprint compared to fuel oil. Finally, is the carbon capture systems, which will be the subject of my presentation today. Carbon capture systems are available today, and most importantly, they can be combined with all the above mentioned technologies as necessary to drop the carbon footprint that's required. As long-term solutions, we have various discussions towards nuclear, which is at a relatively early stage. We have green fuels, which do not actually exist for now, and we have some more exotic solutions such as wind combined with a carbon capture system. So now let's take a deeper dive in carbon capture technologies. First of all, they are separated in pre-combustion, oxy-fuel capture method, and post-combustion from exhaust gas. For shipping, we will concentrate in post-combustion technologies, as such as CCS requires the least alteration to the existing ship designs. Post-combustion technologies can then be separated in chemical absorption, adsorption, membrane separation, and cryogenic separation. The most mature of the above is the chemical absorption using amine chemicals or absorption using ammonia, which we consider to be even more suitable. In this slide, we can see a schematic of a post-combustion technology using ammonia. I will not describe the exact process of this technology, but I will focus on some advantages against absorption using amine chemicals. Firstly, the footprint of the system is significantly smaller as we have a single scrubber tower, whereas with amine chemicals, we usually have 3 scrubber towers for capturing and desorption. The electric power consumption is lower as we have a few water pumps, whereas for the amine chemical, we require multiple water pumps and additional heaters for desorption. Finally, the most significant difference is the after-treatment. With amine chemicals, additional liquefaction or solidification process is required, as CO2 is generated in the form of gas. However, with the technology of absorption using ammonia, the CO2 captured as calcium carbonate is stored as dry powder, which is easy to handle, is non-hazardous, can be traded, and for now at least, the regulations permit to discharge it overboard. So some key considerations which we have to take into account before selecting a CCS should be that the carbon capture technology, due to the capex and mainly the footprint of the existing technology, can realistically reach the EDI, EEXI, and CII targets, but we cannot achieve 100% capturing. Of course, one has to make a techno-economical evaluation for each vessel to examine the footprint of the system, the capex and topex, and the CO2 storage on board, the disposal of it, and what and how it can be utilized. So now let's see some advantages of such a technology. As said previously, the carbon capture technology available today can reach the required target and capture 30–40% to cover the EEXI and CII for the life cycle of a vessel today. It is easy to handle and does not require specific crew skills as LNG or alternative fuels would do. It is an existing and available technology today. And also, in case the vessel is already burning LNG, where still a CO2 reduction might be necessary to comply with regulations, it can be fitted. Even more importantly, it can be combined with a shock scrubber in case the vessel is burning heavy fuel oil. For the ammonia technology described earlier, practically, we still have a single scrubber tower, but with one additional stage when burning HFO. Finally, we will cover some key selection points for a carbon capture system. First of all, it is expected that the cost of alternative fuels will be higher than installing a carbon system, both in terms of capex and later on during operation. Secondly, the cost of paying carbon tax in the future will be a way to pay back the cost of a CCS. Of course, there will be a direct need for a CCS in case the vessel will not even have a chance to pay tax but be banned for trading, in case it has a very small rating for CII. Finally, we have the great possibility of optimization of size and investment by combining the carbon capture system with other existing technologies to reach the required targets, as we have seen with LNG earlier or with various energy-saving technologies. This brings me to the end of my presentation. I wish to thank you all, and of course I can be available for any questions which might be required.
Hello everyone, my name's Gavin Allwright. I'm the Secretary General of the International Windship Association, and I'd like to welcome you all to the second year of the decade of wind propulsion. Now, things have actually been growing quite significantly in 2021 and into early 2022. We've had a lot of momentum growing. That was really kicked off by for example, the Financial Times and The Economist both highlighted the fact that wind propulsion was an emerging technology segment that you needed to watch in 2022 and going forward. Just at the end of last year, the ICS released their Catalyzing the Fourth Propulsion Revolution. And as you can see from the front cover, really started to integrate wind propulsion into that decarbonization pathway. To emphasize this as well, the IWSA itself was granted full consultative status at the IMO, which really brings us up onto the top table when it comes to regulation and decarbonization pathways. And we had quite a number of milestones, but I'll just share one with you that was very interesting. The two largest wind propulsion vessels, or wind assist vessels in the fleet at the moment are a VLCC and a VLOC. And the VLOC was launched last year, and they actually for the first time passed each other just off South Africa. So we had over 600,000 deadweight tons of wind assisted ships passing one another. Quite a historic moment. International Windship Association itself has been growing, and as you can see, we're well above the 130 active members around the world at the moment. So we've seen significant growth in membership, but also, more importantly, in the collaboration between those members, the number of projects that have been developing, and further demonstrator vessels and installations, which I'll talk about in a little while. So just very quickly, I want us to all bear in mind what we're talking about when we're talking about direct application of wind power. Well, you can see a lot of zeros here, but first of all, as a retrofit option, we're talking about 5 to 20% of the propulsive energy being delivered to a vessel. Potential with optimization, bringing that up to around 30%. And these can be deployed across the fleet. Different technologies will fit slightly different segments or be more opportune for different segments. But of course, if we get into the optimized new builds, then we're talking 50% plus can be delivered to those vessels. Of course, with operational changes on particular windy routes, then you're getting really maximizing that potential. But as an energy source, wind energy, it's zero emissions, it's delivered for free for the lifetime of the vessel at the point of use. So it doesn't need to be mined, refined, transported, bunkered, or stored on the vessel. It's directly delivered to the vessel there. And of course, around cost, as we said, you know, it's a free energy source. You know, it really starts to lock in and de-risk future fuel price instability and insecurity. So locking in and creating certainty in a very uncertain world. The wind propulsion technologies themselves, well, on this slide, we're talking about zero development time. Well, that's for some solutions already in the market, and we have a very robust R&D pipeline coming through. Zero compatibility issues. Wind propulsion is compatible with every other choice that you make around fuels for your vessel. Zero additional crew. Pretty much all of these systems are highly automated and will increasingly be integrated into your ship's EMS. And zero capex. There's a nice big question mark there. Some systems are being developed, or models are being developed that can actually lease the equipment rather than having a heavy capex. You're shifting that to OPEX. And we'd like to think of that as a win-win-win situation. Now, the shipping decarbonization challenge, where are we at the moment? Well, in our view, we're looking at this from sitting on a four-legged chair with one of the legs missing. If you want to make that more nautical, maybe change that to a bosun's chair. And the four ropes that are required, you know, to stabilize that, hold it up, and to move it. If you want to take that rope analogy a little further, you know, your mooring ropes. You have four major ropes there. If you're missing one, you've got a problem. So what do I mean by this? Well, there are actually four spokes or four segments around this. And we call this the hybrid wave approach to decarbonization. And if you miss one of these, you're missing huge potential to decarbonize quickly using the technologies today. So each of these segments in the wave, wind, activity, vessel, and eco-fuel, each of these could deliver around 20% with, if they're integrated in. And actually, if you take them out of the silos, for example, wind plus weather routing and decrease in speed, we're talking about some very substantial savings there. All of these reduce the need for, or the level of the eco-fuel that we require. And of course, the question mark there is, you may need to increase the amount of eco-fuel up to 40%. Possibly wind could be 25%. But as a macro approach, these four legs are critical to urgent and deep decarbonization happening this decade. And I'll come back to that in a little bit. So where are we around the facilitation and the policy side of things? Well, as you all know, we have EEXI and CII coming into force, but really becoming extremely important in the 2024-2025 aspect. And then we have CII phase 2, probably ratcheting up the amount of decarbonization that's required. We also have initiatives coming from the industry around the Poseidon Principles, Sea Cargo Charter, possibly the IMRF Fund, carbon levies coming in, the EU ETS, etc. All of these are creating a major push towards an acceleration of the decarbonization pathway. And you'll see from the hatched line that these are working around the same pathway, if you like, that the EU has estimated for wind installations being taken up, around 10,000 by 2030. And we're already seeing a significant uptick. If we have doubling of wind propulsion installations each year from now on, that would actually achieve that 10,000 installation level, pushing that up to 50,000 in 2050. So where are we today? Well, with large vessel installation, we have, by the end of 2021, there were 18 ocean-going vessels. We didn't quite make the 20 that we hoped for, but we had another one wind-ready vessel as well in operation, and 20 small sail cargo fisheries and cruise vessels in operation. So actually altogether around 40, but let's focus on the big 18 at the moment. Each of those are in, Those are in different segments. You'll notice that we don't have container ships yet in this market. There are a number of AIPs being granted for new build containers. And of course, things like kites could be applicable as retrofits on existing container vessels. The pipeline as well is strengthening, and we actually have around, I think it's 14 or more vessels that have already been announced as retrofits and new builds coming through. A couple of new builds are already underway. So we can see significantly probably by the end of 2020, end of 2022, Q1, Q2 2023, doubling the amount of vessels that are in operation. And these are some of the forecasts. I've shown this slide a few times before, but we use third-party forecasts, and the EU has forecasted up to 10,700 installed systems, but using a very limited baseline for that, which was only looking at 4 technology groups and focusing only on containers, tankers and bulkers, but tankers and bulkers being the primary one. Ro-ros were left out of that, etc. Small general cargo vessels as well. The UK government, in their Clean Maritime Plan, estimated market penetration around the 40 to 45% of the global fleet by the 2050s. We feel internally that both of these are conservative, and especially looking at the fuel issues that we have currently, and also the instability in fuel, that this could go much quicker. Now, a final sort of return to the decarbonisation challenge. How would all this fit in on a macro level when we're talking about the finance and the way that wind propulsion could actually facilitate the rest of the decarbonisation? And this was a thought piece that we did last year, using very conservative fuel prices, as you'll see, a $500 per ton of fuel averaged out in the 2020s. We're obviously substantially above that, but if that's likely to come down maybe in the next couple of years. However, if we look at wind propulsion being rolled out significantly, and we're talking across virtually the entire fleet within this decade, the cost for that would likely to be around 200 to 300 billion. You know, more for larger ships, cheaper for smaller ships, but averaging out around a 20% delivery of propulsive energy. That includes new builds and includes retrofits. That would actually deliver over the next 3 decades enough finance or enough fuel saved to deliver 1 trillion in savings. And that's what the UMass and ETC report has estimated would be the cost of implementing IMO 2050. And indeed, if these prices increase, actually would probably be able to deliver the complete cost of decarbonising shipping. So it covers its own cost and then covers the cost of all of the new fuels coming through. Now, of course, this is on a macro level, and these are basic numbers, but I think you'll get the idea that wind propulsion can really facilitate the decarbonisation of the fleet as standalone, but also as a facilitator for others. And this is my final slide. All of these companies that are listed here are engaging in some way or form with wind propulsion today. Some of them are ordered vessels, some of them already have installed vessels or are developing technologies to do so. And we see this again as a win-win wind propulsion situation for all. Thank you very much.
I would like to thank everyone about today's presentation. I'm Dr. Konstantinos Galanis, the chairman of the International Ship Recyclers Association, and I will discuss about the European Union taxonomy and its relationship to the ship recycling. I think it's a very interesting topic following the last year's presentation regarding ship recycling sustainability. So what is the European Union taxonomy? It is actually a classification system establishing a list of environmentally sustainable economic activities that are actually assisting the European Union to scale up the sustainable investment and implementation of the European Green Deal. Green Deal, probably you have heard a lot of discussion. Going forward, the next decade, we will hear a lot of interesting developments. It is actually the transformation of the European Union into a modern, resource-efficient and competitive economy. Nevertheless, it actually has to ensure that no net emissions of greenhouse gases will be emitted to the environment by 2050, and this is actually where ship recycling can actually assist to minimize the environmental footprint of the vessels if it's actually implemented in the proper way based on the ship recycling directions and requirements. Secondly, the economic growth that has to be decoupled from the resource use, and this is one of the most important actually support and addition of the ship recycling to the ship life, where we actually can minimize the resource use by several means. And of course, the third parameter that is actually no person and no place will be left behind. And definitely ship recycling has a room of actually the involvement of the engaging of several experts and workers to assist on this perspective. The European Union taxonomy actually provides to the companies, investors, and policymakers with the appropriate definitions for which economic activities can be considered environmentally sustainable. And as I have said last year, environmental sustainability is one of the main parameters that most, not to say all, the transformation means are actually heading to. We need to define, allocate, explain and implement ship recycling in the proper manner to ensure we will assist the European Commission and the international framework to head in the future. It also creates security for investors from greenwashing. That is one of the most important parts within the ship recycling. We have a lot of vessels actually going to non-environmentally friendly locations about ship recycling of the vessels, and actually will help companies to become more climate friendly, mitigate market fragmentation, and help shift investments where they are most needed. And ship recycling plays a significant role on this perspective. Why we need the EU taxonomy? EU's climate and energy targets for 2030 are actually focused on investments that has to be directed towards sustainable projects and activities to make our economies, business and societies more resilient against climate and environmental shocks. If we take a look into the benefits of the European Green Deal, that actually here you can see several schematics, we can focus on the ones that actually have been in this red framework that are related directly with ship recycling. For example, regarding the fresh air, clean water, healthy soil, and biodiversity, where ship recycling plays a significant role since all our vessels are actually operating globally and ending up in a location to be recycled, where we have mainly to protect the biodiversity in several ways and apply all the rules and regulations, not only the national, the regional, but the international ones. It discusses about cleaner energy and cutting-edge clean technological innovations. Here is where for ship recycling, we need to put some emphasis to make sure that the emissions overall produced by the shipping business can be further minimized by following the proper ship recycling practices. Also, we are discussing about longer lasting products that can be repaired, recycled, and reused. Definitely, it goes beyond any discussion that ship recycling is the proper way of achieving this particular target. We have the future-proof jobs and skills training for the transition of the energy to reach these goals by 2030, 2050. Definitely ship recycling, we have the need of the inclusion of additional members, especially environmental experts, where we can actually implement, innovate, and make sure that the transition in an environmentally friendly way, we will be able to provide this particular sector in our shipping cycle to make sure that the goal will be achieved. And of course, the globally competitive and resilient industry, whereas we need to build more facilities worldwide under the environmentally friendly, based on the requirements set by the European Commission and the IMO relevant regulations like the Hong Kong Convention, to make sure that the ship recycling will add value to the benefits of the European Green Deal. The taxonomy regulation and the delegated acts are actually in force since the 12th of July 2020. And the basis has been established for the EU taxonomy by setting out 4 overarching conditions in order an economic activity to meet and qualify as an environmentally sustainable option. These 4 conditions are actually presented with this slide, and we need to substantially contribute to one or more of the environmental objectives. Definitely, ship recycling is heading to this direction. This is one of the main parameters that shipping companies should take into account. Do no significant harm to any of the other environmental objectives, and this is, satisfied also by the proper ship recycling. Be carried out in compliance with minimum soil and governance safeguards, and of course we tick this box. And finally, comply with technical screening criteria, which the Climate Delegated Act set out in relation to climate change mitigation and climate change adaptation. What do we mean by all of this, and by the 6 environmental objectives described within the EU taxonomy regulation? Ship recycling actually applies and supports the climate change mitigation adaptation, and of course provides protections of water and marine resources as long as it's been done with the proper way and based on the EU ship recycling regulation, the IMO Hong Kong Convention. Transition to the circular economy. Of course, this is one of the parts and the elements that the shipping companies have to consider to ensure this transition phase will be done in the the best possible way by optimizing their decision and the actual implementation by the ship recycling facilities. Pollution prevention and control goes beyond any question that we are here to support all these measures to ensure that we will avoid the ship recycling in areas and facilities, especially the subcontinent, that do not meet these criteria and requirements, and of course protect and restore the biodiversity ecosystems. In order to be able, from the ship recycling perspective, to ensure that this value and this way going forward of the EU taxonomy will be satisfied, we need to be able to have the applicability of the regulations being presented in this matrix within the ship recycling framework. And of course, the flag of the ship is actually guiding the direction that the vessel should follow. Of course, we are supporting, as International Ship Recycling Association, the use of the European flag ships, where this is the only way to ensure that the vessels will be recycled in the proper manner and way, following the highest criteria and requirements. Whereas if the vessel is non-EU flagged, we'll have some options that, of course, with the Basel ban amendment, we are trying to ensure that we'll minimize the end-up solutions where the ship recycling facilities do not offer the proper environment to recycle our vessels. I'll remind you once again what I have presented the previous year in the same virtual forum, that for all these ways, and in order to be able to achieve all these goals, we have to make sure that the safety of the workers and the environmental protection will be at the top of our agenda. the ship owners, the shipping companies, and all the people within the shipping industry have to understand that we need our human resources and we need to protect our environment. And in order for a vessel to meet this target and this goal, we should design, we should operate, and we should recycle our vessels properly to have a complete set of operations and compliance to proceed in the future regarding all these interesting developments that have been set by the European Union. I would like to thank you for your time, and of course I'm always available in any questions that you might have, and you can submit to the GREEN4SEA Virtual Forum, which I have to thank for hosting this presentation. Thank you very much.
Yes, hello, and thank you very much for giving me the opportunity to present the strategies for the identification, selection, and control of recycling yards for ships which have to go for recycling. It's a matter of time when anything becomes waste, no matter how nice and shiny anything is today. Once the day will come, and the question is, what can be done for ensuring a proper recycling? So not only that it's under public scrutiny in many cases, each and every company should think about their own corporate social responsibilities and other ESG compliances or compliance factors on what needs to be done with the old assets, basically. So a common process which I'm presenting here consists of 4 major steps. The first one is doing the homework, understanding what does compliance and proper recycling really mean. What are the legal basics and the boundaries? What other organizational and technical requirements are to be considered? That's a general task. Now we have the task for the individual project. So what are the hazardous materials on board or inside this maritime asset? What are related specific requirements? How can we select a proper and capable ship recycling yard? And what needs to be reflected in the contract? The third part is then really bringing the ship or the maritime asset on its way to the recycler. I'm not going to go into too many details here. And the fourth part is what's going to happen during the recycling process. What aspects need to be supervised and taken care of? What about waste disposals, reporting, and so on? That's the entire project, and now I'm going into further details here. So the first part, the legal requirements. This is already a big obstacle and quite challenging for many. So we have various legislations, international conventions, amendments, regulations, and so on and so on. And it's not so easy to really figure out what applies to a certain ship, for instance, because quite a few of these conventions are directly connected to the position of the ship when the decision for recycling is taken. And also, for instance, the ports of call after the decision has been taken. Each and every destination has its own legal regimes and requirements, or a combination thereof, and they need to be investigated carefully. And of course, we need to ensure legally compliant processing in any case. So we have the international and regional approaches. We have national legislations. We have technical guidelines from various industries, for instance, but also from legislators, and so on and so forth. These are creating the basis for whatever is going to come next. Based on that, a strategy needs to be developed. The first part here showing the legal compliance and certification has been explained before. But what about the general organizational aspects? and also further factors like labor and human rights, anti-corruption, and so on. There are so many different initiatives and requirements within the maritime industry, so all need to be reviewed for really having a solid and sound recycling strategy for the responsible ship owning company. So further on, as mentioned before, what is to be recycled? What ship type, the size, the hazardous materials on board, other residues, what capabilities are required from the ship recycler to handle all of those in a safe and environmentally sound manner. So these are all aspects which in this case are project specific, the other one are the general aspects. Knowing this can be used or should be used on knowing what the recycler needs to provide. So, and these different capabilities need to be vetted. In case there are a number of different recyclers, I should go there and evaluate whether or not the capabilities are as described. So we have different categories from organizational aspects, training aspects, social aspects, layout, equipment, the recycling method itself, and so on. Those need to be investigated in the field, in these yards, and the different categories should be, or should get some weighing factors. So, and with these weighing factors, we come down to certain numbers according to the results of the vetting inspections. And that makes it quite easy and quite obvious which recycler really offers the best solution. When we do that for our clients, we always take care that mandatory and very important aspects can't be overruled by less important aspects. And this needs to be reflected in the numbers or the scores and the weighing factors as well. All the different requirements which have been developed in the first stage and which have been adopted to the ship-specific conditions need to be reflected in the contract. We usually work with a recyclicon developed and provided by BIMCO. It's a very good basis, but it needs to get more meat on the bone. For instance, in terms of delivery or handover, reporting requirements. What does the recycler has to report? And we always include a performance bond and related milestones. Once these milestones are met, a part of the performance bond will be paid to the ship recycler. In most cases, as soon as the ship is delivered to the recycling facility, there is no option to get the ship back. And if the recycler is not performing, what can the seller or the previous owner do? This is really, really tricky. And for that, we have the performance bond. But the milestones need to be defined extremely well and clear so that not further disputes are arising from those aspects. And of course, supervision. We always suggest to look for third-party independent supervision. If the supervisors are coming from the sellers, they might have different interests than those supervisors coming from the buyer side or from the recycler side, or the intermediate like cash buyers. So the supervisor always has to be independent, but he should not only act as a policeman, he should also act as an advisor, because it's our all common goal to ensure safe and environmentally sound recycling. And if the supervisor sees any risk appearing or coming up, he should raise awareness amongst all who can change that. When we look into the supervision of the recycling process, and here's a long, long list, and these are only the main headlines. These are the requirements applying to ship recyclers for being Hong Kong Convention compliant. The same requirements apply to EU, where some additional bits and pieces have to be considered as well. It's a huge number of completely different aspects which we need to cover during the daily operations and supervisions. And this needs to be reflected in the report, for instance, in the photographs, where we say, this is right, this is wrong. What further action has been taken? Who has been informed? Who is responsible on site to change risky conditions? Or if everything is good, we of course report that as well. But by its true nature, we focus on the difficult areas and to make sure that these are handled in a very compliant way. So the findings and observations need to have a proper follow-up, not only in regards to quality documentation, but also what we see in the field, what we see in regards to prevention of falling from height, gas-free for hot work conditions, labeling, monitoring, first aid stations, anything which is related to emergency preparedness, drills, storage of chemicals, hazardous wastes, and so on and so on. So it's a huge variety of different aspects. And if any non-conformity or is found, it needs to have a proper follow-up as well and a nice reporting. So, and once the job is done, we need to document where all the waste have gone to. So what has happened? How much waste was generated? What were the valuable materials? So without that, we can't really show where all the materials have gone to. But the transparency in this process is extremely important. The conclusions: the legal and individual aspects create a set of requirements, but they require a lot of homework and preparedness. Due diligence inspections are required for the on-site evaluation. Never trust certificates, papers, plans, whatsoever. Go there, feel it, talk to the people. And if a ship owner does not have the right experience and knowledge about all these things, involve those who have a proven track record. Not those who are shouting the loudest, but those guys who really know what they are talking about. Benchmarking of the potential recycling facilities is essential. So make sure that all your demands and criteria are met in the best possible way. So, and as said, ensure, for instance, that the financials can't overrule crucial performance aspects. First comes quality, and then we talk about economy. And in many, many cases, one is not against the other. It can be combined if the right facilities are known and chosen. Include all the specific conditions and general conditions in the contract. Create a transparent process. Supervision is essential, and also in case something happens. We talk about heavy industry, like shipbuilding, like construction. Something can happen. But show that you have acted with utmost care to prevent any adverse effects, any damages, incidents, or accidents. And this is an obligation for the seller as well as an obligation for the recycler or buyer. That's it from my point of view. Yes, and I hope that my presentation was found to be interesting, and I look forward to the further event. Thank you very much.
Good morning, good afternoon, or good evening, everyone. My name is Yuvraj Thakur, and I represent a company named Verify Shipping as the CEO of company on the IHM side. Today, I'm going to present you the topic of IHM maintenance, inventory of hazardous material. As you must see, you all must have seen and heard this topic before. I'm going to present to you this topic in detail today. So what we have in front of us is a presentation, which is divided into three different parts. part number 1 of our presentation is what exactly is IHM maintenance. Essentially, we are going to tell you, what is IHM maintenance, what are the rules, what are the regulations, what are the authorities talking about it, and what you need to do. I mean, what you need to provide in terms of being in line with the requirements of the regulation. So essentially, we are, putting together a problem. We are the one that is, loud and clear about the fact that, hey, there's a problem, and we need to solve this. Which leads us to second part of our presentation, wherein we talk about the systems, processes, and solutions. So here we talk about, how we have solved this problem. What we have done essentially to solve the problem around IHM maintenance, what kind of platforms, what kind of dashboards have we created, and what kind of services are we providing. And the third section of our presentation is then, why choose very far away shipping? Who is very far away shipping? What do we do? Where did we start? And, why would you like to, come with us as partners on this very important topic of IHM maintenance. So to begin with, as you know, the regulation HKC, Hong Kong Convention, it is like the mother of all requirements on IHM. It has been a work in progress since 2009, and it is still not ratified. We are waiting for the day when it would be ratified. But the European regulation EU SRR, Article 5 and Article 12 of these regulations, they take a lot of guidance from MEETS PC and HKC. And within these documents, Article 5 and Article 12, they very clearly mention that Part 1 of inventory of hazardous material, it should be properly maintained and updated throughout the operational life of the vessels. So, it is a part of the requirement of the EU SRR regulation, Article 5 for the vessels that are EU flagged, flying the flag of an EU country, and Article 12 are the vessels that are flying a flag of third country, but calling an EU port. So you must have an inventory of hazardous material, which is maintained when calling an EU port. What do you mean by this? I mean, now the question is, how do you maintain the inventory? So when you say how do you maintain an inventory, it means that you need to collect some sort of documentation to be able to showcase or to be able to prove to the class societies, to the port state control inspectors that, hey, the inventory has been maintained. So how do you do that? All your suppliers, essentially all your supply chain, it has to be looked at in a very deep manner. It has to be looked at in a very sustainable manner. And your suppliers must provide a supplier declaration of conformity, named as SDOC, and material declaration, named as MD, for every product delivered. So on these documents, there should be a detailed description of products that are delivered to the vessels or to the office. And finally, it also applies to downstream suppliers. So this is a very common question or query from shipping companies that, hey, only my supplier has given me the declaration. So it's not about your supplier, it's your supplier, then the tier 1, tier 2, tier 3 suppliers going up to manufacturers. So essentially the regulation wants to understand and find out what material was used and whether there was some chemical used when this item was being prepared. And why this is so important, why we have such a focus on this topic, because it's a class requirement. Your ship owners, you as ship owners, as ship managers, you must maintain the inventory throughout the operational life of the vessel. Of course, the duration of SOC is renewable every 5 years, but sometimes we have seen that this is also reviewed, IHM Part 1. And the fact that whether IHM has been maintained or not, this is also reviewed during the annual class survey. The review at the time of class survey must provide confidence that the vessel has been following procedures. They have all the MDs and SDOCs, and they have declarations that are in line with the requirements of the regulation, and all the potential hazardous material are included in these requirements, in these documents. And finally, these documents must reflect the updated IHM Part 1, which is a result of your continuously maintained IHM. It should be a fair representation of hazmat on board. It should be clear, it should be concise, and essentially we zero down to the fact that IHM is a live document. It's not something static and something to be kept aside. It's a live document. It requires regular updates, and it must be maintained by dedicated and certified people. which now brings us to the solution that we have created. So, like I said, part one of the presentation, we have been loud and clear about what is the problem and what needs to be done, what needs to be provided. Now we come to part two of our presentation, and we talk about the solution. So the solution is, Verifavia's team, we have come up with our own supply chain. We call it a three-way plug and play IHM maintenance dashboard. So we are all marine engineers and naval architects with an average experience of 5 to 7 years working on board the vessels. So we know that what is happening on the other side. We know what is needed, what is done, how a material is is taken on board, and how do you even maintain an inventory when you're on the vessel. So we essentially provide you a platform wherein you can fully outsource the process to our team of hazmat experts. When we say hazmat experts, it reflects the team that has completed more than 1,000 surveys in the last 2 years. That reflects the most accredited IHM team in the world. We have 8 classification society and 2 flag state accreditations, and major fact being none of our IHM reports has ever been rejected by any classification society. So we will be the committed person to support and supervise the IHM maintenance process on your behalf. We will be the appointed designated person for IHM maintenance. We ensure conformity of process with the legal deadlines. Like we said, because we are ex-seafarers, we know how to review a PO, we understand each and every material. We are in a better position to liaise with the suppliers to collect MDs and desk stocks. And when these MDs and desk stocks come back, we continuously update the IHM Part 1 report and issue an updated report. And very proud of the fact that in the last year, the average time when PSC has been on board and a request has come to Verifavia to provide an updated IHM maintenance report, the average time has been 10 minutes. So, our team really understands the emergency on board. They really understand the situation on board. And, we take all the headache off your shoulders and pass it on to us. We are the ones maintaining IHM on your behalf. As you can see, this chart is the reason why we named it. It was a very fancy term at the beginning. So, we named this a three-way plug and play IHM maintenance platform. So, we have a dashboard in place, which is connected via an API to your procurement system. All the major procurement systems in the market, if you name, they are connected to Verifavia's dashboard. A lot of suppliers are now connected to Verifavia's dashboard, and I'll touch upon this in the next slide. So suppliers can actually create MD and desk stock on our platform within 30 seconds and link it to our dashboard. And finally, all the work, once it is done on Verifavia's dashboard, it is presented on HasInvent M, which is a simple to use, easy to load, web-based platform. You don't require any software to load onto vessel's computer or something. Just go onto the website. Vessel users, office users, PSC, EMSA, flag state, classification societies, anybody can log on to this HasInvent M, which is our platform, and look at the inventory, whether it is maintained or not. And the slide now, it gives you essentially an overview of the system. So the job, once this job is outsourced to Verifavia, the job then of a ship owner or manager is to log into the platform and download any ad hoc IHM certificate of reports as and when needed. The vessel can do it directly. Verifavia's team, they take care of the suppliers, they take care of the supply chain. They are the one who's performing heavy lifting. We are the one collecting, analyzing, reviewing, and archiving MDs and desk stocks and maintaining IHM at all times, getting in touch with the suppliers, liaising with them, and making your documentation ready for PSCMs or flag state. So here, this was the system overview. And now finally, I touch upon the fact that we have recently launched a platform wherein we found out the fact that a lot of suppliers in the market, they were lost. They were lost with the new requirements. They did not know what to do. They did not have awareness. The supply chain was really inefficient. The MDs and desk stocks were not coming back as correct. There was lack of resources at suppliers, and lots of time was needed in creating and filling this declaration. And of course, pressure from shipping companies and from IHM maintenance companies like us to provide the right document. So again, the problem was, loud and clear, and very quickly Verifavia's team, they came on with a solution. So We have now developed a suppliers dashboard portal, a very simple, very easy to use portal wherein suppliers can generate MDs and stocks of multiple vessels, multiple POs, hundreds of vessels, hundreds of POs in less than a minute. And we can the record of suppliers can come onto our dashboard. The dashboard creates MDs and stocks. There are proper user guides, around the clock assistance, and I'm very happy to share the fact that the first few suppliers have already started signing up to the platform, and they are using the platform on a regular basis. So, if there's any supplier out here, if there's any shipping company out here that needs support on IHM, please let us know. Finally, why chose Verify via Shipping? Some of our credentials, like I said, we are the most or one of the most certified IHM company in the world. We employ a team of 50 plus hazmat experts, which means that in case you have a hazmat survey requirement as well, let us know, and we will we'll be able to answer that query. These are some of our approvals. 8 major classification societies and a couple of flag states. Some of our achievements in the last 3 odd years. We have maintenance program running at this moment on more than 2,000 plus vessels. We are in touch with more than 1,500 vessels. We have completed 1,000 plus IHM surveys. We have used more than 50 experts. Reports of 900 or 950 have been submitted to classification societies. We follow a lot of stringent, ISO 9001 and ISO 17020 level processes. We audit our laboratories. We have experts who are approved by DNV, KR, and ABS. And this is a list of some of our clients. I mean, some of these clients are in your region as well. So feel free to call them up and take a review of our feedback and our service level. And finally, why choose Verify via Shipping? As I have said, that we have a very clear understanding of the requirements. We are IHM hazmat experts plus marine engineers and naval architects. The platform that we have provided is a plug and play solution. It's simple to use. It's easy to load. We help you stay compliant with the requirements of the regulation. Like I said, very proactive services that we have, and we save ship owners from penalties, and now we also safeguard suppliers from potential penalties and potential loss of business due to wrong or incorrect declaration. With this, I would like to thank you. And here is our team. Myself, I am now the CEO for the company, and Mr. Julian Dufour is the chairman of our company. Anytime you need any assistance, feel free to let us know. Feel free to call us on our numbers. You can go to Verify via Shipping website to contact us as well. And with the last 3 lines that we have been really flagging out in the last years. So please prepare, please maintain your IHM, and navigate freely with peace of mind. I would like to thank you and wish you a great day ahead and a great time at the Safety for Sea conference. Thank you. GREEN4SEA conference. Thank you.
Viewers and friends, good day. We are so happy to welcome you once again to this year's GREEN4SEA Awards with the aim to recognize industry's outstanding practices for a more sustainable and greener maritime industry. Currently, decarbonization is one of the biggest challenges the maritime ecosystem has ever faced, but it might also present a great opportunity. A greener future is a key issue of discussion among all stakeholders who have realized that investing in sustainable practices is critical and part of their ESG strategy. ESG stands for environmental, social and governance and has become the new trend within all business sectors and not only maritime. Actually, it is not a trend, it is a necessity. In that respect, Safety for Sea is always on the run to contribute to the promotion of green-based policies and ESG efforts within our industry with the aim to foster environmental awareness and sustainability. Thank you for joining us, and let's start with the awards procedure. Now that many organizations are promoting their ESG agenda as an effort to show honest contribution towards a more sustainable future, let's take a look at the short-listed nominees for the 2022 GREEN4SEA Sustainability Award. The 2022 GREEN4SEA Sustainability Award goes to RightShip. Congratulations! Let's get to watch the relevant video. are now joined by Mr. Gurpreet Singh to accept this award.
Hi everyone, it's a real privilege to accept the GREEN4SEA Sustainability Award on behalf of RightShip and our CEO Sten Lund in recognition of our continued work in the sustainability space. Ever since joining RightShip as CCO last year, I've been very honored in working with brilliant colleagues, including our global sustainability team led by Chris Famberger, based out of Melbourne. At RightShip, we are steering the maritime industry towards a sustainable future. When a customer uses one of our sustainability products, they are protecting the natural environment, developing competitive advantage, and improving their bottom line. As an environmental, social, and governance-focused maritime digital platform, sustainability is one of RightShip's 3 strategic pillars, alongside social responsibility and safety. These complement our vision of a maritime industry causing zero harm, along with our mission to be a trusted innovation partner, charting a safe, sustainable, and socially conscious way for a future in the maritime industry. To achieve this, we help those who own or charter ships to carry their cargoes in the most environmentally friendly way. We can show how environmentally friendly the actual design of a vessel is, along with its emissions on a voyage. Our data also helps ports and terminals around the world assess which vessels they want to encourage entering their harbors, giving them the opportunity to reduce the environmental impact. Chris and his team have excelled over the recent years, developing solutions such as carbon accounting tool, which measures the emission volumes and intensity of ships. We are about to launch to the mass market a similar solution giving ports and terminals the power to do the same, focusing on the vessels entering their port waters. This allows them to manage the impact of their local environment, which is a positive step for us all. And at RightShip, we never sit still. We continue to develop more wide-ranging solutions for the maritime industry and ecosystem that keeps us front and center in our aim of achieving a zero-harm future. So once again, thank you for this award. RightShip will, for one, continue searching innovative solutions, leading to a cleaner and more sustainable environment for everyone. Thank you.
Let's move on to the second category for today, clean shipping. This award aims to showcase environmentally friendly practices that are focused on the protection and restoration of the marine and atmospheric environment. Let's take a look at the shortlisted nominees of the 2022 GREEN4SEA Clean Shipping Award. And the winner is EEXI. Congratulations! Let's hear from Mr. Stevens Hoetsbrood and Captain Mehmet Mazman a few words about the winner.
Thank you everyone from a warm and sunny and lovely Cyprus. I assume no one's been slapped during this event, making it a already classier and much more dignified award ceremonies than others going on at the moment. It's always an honour to accept awards on behalf of other people, and this is absolutely no different. The IC team has grown really quickly. It now consists of hundreds of dedicated companies, thousands of even more dedicated seafarers, and a large number of incredibly dedicated people giving their time and effort into solving this large and unfortunately growing problem. I spend a significant amount of my time looking at the technology that we build, thinking about how we can use it better and thinking about how we use it in different ways. And when Graham came to me and told me about this idea, I quickly understood that the only difference in what Chartworld does as a business venture and how it could support IC was willpower. Yeah, the will to solve this problem is required by millions of people. But I believe with the right technology, support and guidance, we can find 1 million people that want to solve this problem. Yeah, they have the will to get this done. We all love our oceans. We love being on them, in them or under them. We love what they do for us, and we have the will to change. While none of us are doing this for recognition, it's really important for me to share a few names that have made a huge impact over the last 12 to 18 months for IC. Ian Cameron, Rebecca Trafford, Isabella Estetheu, Romeo Sario, Richard Groves, Julia Sestokas. Thank you for providing your will to the IC project. And of course, I can't not thank Kath and Graham. Your drive, your leadership, your vision, it's infectious to all of us, and we really look forward to being part of this project for a long time to come. Thank you everyone, and I hope you enjoy the rest of you. Goodbye.
First of all, I wish a great day to everyone. I'm Captain Mehmet Mazman, working for Oldendorf Carriers, and I'm on board motor vessel Louisa Oldendorf as captain. In addition, I'm one of the seafarers who has been testing the IC application during the beta testing period, and I'm the first person appointed as at-sea ambassador of IC. As a seafarer, our profession is to cross the ocean, so see the pollution at the middle of ocean and report is easier for seafarers. This is why we should involve as many seafarers as we can in IC organization. I would like to relay my thanks to everyone who gives their support and their vote to IC for GREEN4SEA Clean Shipping Awards. I have to admit that this award honored us and motivate us to focus more and work harder.
With climate change emerging as a top threat, leading maritime organizations are taking the lead in improving the environmental performance of international shipping with several initiatives. Let's take a look at some of them. 2022 GREEN4SEA Initiative Award goes to Windward. Time for the video. Congratulations! Let's hear from Mr. Ami Daniel the concept behind this initiative.
Hi everybody, this is Ami Daniel from Tel Aviv, from Windward. We'd like to thank everybody at the Green4Sea team, in the ecosystem, in our team, and all our partners for being elected as the Initiative of the Year award for data for decarbonization. If we take a step back, shipping emits about 3% of the world's carbon emissions, but it's on track to be 10% of the world's carbon emissions. And with everything that's going on in Russia, in Ukraine, and all the conflicts, and in Shenzhen, and the shutdowns and the lockdowns, there's one thing that has to keep on ticking and happening, and that's global trade. But at the same time, we as an industry cannot take our eyes off the ball. We cannot forget that we only have one planet, and if we don't act now to reduce the world's carbon emissions, we won't have another planet to live in. And therefore, we at Windward are committed to work with our partners that have taken a step forward, share data, expertise, giving their time to build a real technological solution based on AI to measure and reduce shipping's carbon emission going forward. This is a goal that we cannot forget about. Thank you everybody, and we'll see you soon.
Now we move on to the fourth category for today that recognizes significant technological achievements which reduce environmental footprint and achieve energy and fuel efficiency. Let's view some of them. Congratulations Bird Propulsion for winning the 2022 Green4Sea Technology Award. Let's hear from Mr. Jonas Nyberg a few words on how their technology accelerates electric propulsion.
Hey everyone, I'm Jonas Nyberg here on behalf of Berg Propulsion, here for something very exciting, and that is to accept the 2022 GREEN4SEA Technology Award for our nominee, the Direct Drive Electric. Something that we believe will have a big impact in the marine industry, a technology that delivers increased efficiency at better safety and reliability aspects in marine merchant vessels and workboats. This for us started out a few years ago when we set out to really deliver and develop something that is just a little bit better than anything else the marine industry had seen today. And that ended up with our direct drive electric solution being a very large permanent magnet electric motor driving a propeller shaft directly, with a great innovation with how we actually put this together in the compact way that we do. We did this together with our partner Canada Steamship Lines, which is now operating a 26,000 deadweight self-on loader in Canada, carrying this equipment, where Berg has been the partner delivering the system integration to that vessel. This vessel, built in China at Chengxi, is really something very beautiful and something that will have a big impact into the marine industry. So we thank GREEN4SEA and Safety4Sea for the chance of nominating and getting this award, and we thank all of our customers around the world for voting for us in this solution that we believe will be very significant going forward in a marine industry focusing on environmental footprint, safety and reliability. Thank you very much.
The tanker market in the maritime industry entails many challenges and risks. With this award category, we are happy to shortlist few candidates who have excelled in demonstrating environmental performance. Let's see the shortlisted nominees for the 2022 GREEN4SEA Tanker Operator Award. Of the Tanker Operator Award is Maran Tankers Management. Congratulations to Maran Tankers. Let's watch the video explaining why they won this award. Mr. Mark Pearson will accept the award on behalf of the winning company.
Hello everybody, I'm Mark Pearson, the Managing Director of Marine Tankers, and with great pleasure I accept the award of the 2022 GREEN4SEA Tanker Operator for transforming our fleet with the order of the dual-fuel vessels. MTM's mission is to provide world-class shipping service to our clients across the tanker markets in a safe, reliable and sustainable manner, whilst embracing the energy transition through innovative solutions for zero-carbon vessels. The order of the dual-fuel vessels is a key step along the road to achieving this mission. We believe that dual-fuel LNG-powered VLCCs are a pragmatic solution for the next 15 to 20 years until zero-carbon technology reaches maturity and is ready for use on large tankers. We ordered these vessels capable of consuming LNG, VLSFO and MGO at Samsung Heavy Industries. Samsung was selected as they have a reputation as one of the leading experts on LNG fuel technology worldwide. The ships will be delivered in 2023. They can achieve a 40% lower EEDI compared to the EEDI Phase 0 baseline. In other words, the ships will be 40% more energy efficient. This is due to a combination of efficient machinery and hydrodynamically optimized hull form, propeller and energy-saving devices. The vessels will also be propelled by the latest generation high-pressure Tier 3 engine, which is a gas engine with high reliability and the lowest methane slip currently available in the market. Other features of the ships include shaft generators, energy-saving pumps and fans, AI-based collision avoidance solutions, high modulus ropes for mooring, and also many other innovations. We're looking forward to welcoming these ships into the MTM fleet, which will not be possible without the tireless efforts and commitment of the MTM team in designing and building the vessels at Samsung. In parallel, we keep supporting the technology that will transform shipping to a zero-carbon industry. We're committed to work with integrity as a foundation of our business to deliver cargo in a reliable manner and to promote and to encourage to create the vessels of tomorrow. As a last note, I would like to deeply thank the organizers and everybody who voted for Marine Tankers. Thank you very much.
The dry bulk sector is an exceedingly demanding segment whose multifaceted nature has inevitably ups and downs. Under these circumstances, the GREEN4SEA Dry Bulk Operator Award has an added value. Let's take a look at the dry bulk operators who have contributed towards cleaner and greener shipping. The 2022 GREEN4SEA Dry Bulk Operator Award goes to Norden. Congratulations! Now it's time for the video. Let's invite Mr. Henrik Rodel to receive the award on behalf of Norden.
Hi, I'm Henrik Rodel, Head of Decarbonization at Norden. The world is facing a climate crisis, and at Norden we are proud to be at the forefront of the green transition in shipping. We've made a firm commitment to net zero emissions by 2050, and we're now making tangible progress towards this goal. We are committed to reducing carbon from our operations below the Sea Cargo Charter trajectory and are bringing transparency over emissions to our customers with the introduction of carbon emission reports for every voyage. We've also launched our first 100% carbon neutral biofuel sailing option, and more green freight products are now under development to provide the solutions our customers need to decarbonize their supply chains. There's still a long way to go, but I'm very pleased to accept this award from GREEN4SEA as recognition of our progress on this journey. Once again, thank you for the recognition.
Now it is time for two special GREEN4SEA awards dedicated to individuals that have provided industry leadership and contributed towards greener shipping throughout their careers. The 2022 GREEN4SEA Personality Award, sponsored by Irma First, is targeting an individual who influences and inspires greener days for shipping. Congratulations to Mr. Stamatis Bourboullis, who has given the example towards a more sustainable shipping. Let's give the floor to Ms. Eleni Polychronopoulou to make the introduction.
Stamatis Bourboullis is a role model in the shipping industry. Raised in the shipping family of Panos, Mr. Bourboullis learned to love the vessel close to people that actually lived on board. For 17 years, he has been leading Euronav, one of the greatest shipping companies. He has a rich knowledge and a vast experience and has been part of the strategic development of the company. More importantly, he has gained the respect and admiration of his peers for his rare leading skills and his contribution in the industry. Shipping needs more people like Stamatis. Stamatis, congratulations.
And now, a few words from Mr. Stamatis Bourboullis.
It is my pleasure and honor to receive the GREEN4SEA Personality of the Year Award for 2022. After starting my career in the chemical industry for about 3 years, I had the chance to continue in shipbuilding, ship repair and shipping industry for the next 37 years. What in my opinion makes shipping so interesting is the continuous change and evolution in all aspects. Every day can bring new challenges, and the response to these challenges offer a feeling of creativity that also brings quite clearly an indication of the results of your job. I have many memories of both successful and unsuccessful results, many times due to my mistakes or omissions. Having a second chance, I realized how important it is to try to learn from the mistakes or the failures and turn them into experience. Beyond my family, my teachers, friends, who laid up the foundation of my personality, I have met many people in shipping that helped me to develop both personally and professionally. Sometimes in a hard way, but I still remember many occasions that although at that time were quite unpleasant, proved to be very supportive in the long term. I have worked with companies that motivate people for looking for continuous improvement, but also be resilient and can withstand adversities. All the above indicate the value of teams working together for common goals, where by offering your best to the team, you get by return the best from your team members. So what you become at the end is the result of this valuable exchange. I want to thank all who have offered me their cooperation and have inspired me in many ways. And of course, I would like to thank the editor and the editorial staff of Safety4Sea for offering me this distinction and wish them all the best in their effort for sustainable shipping. Thank you very much.
Last but not least, the 2022 GREEN4SEA Leadership Award, sponsored by McGregor, recognizes an individual who has pioneered within the maritime industry, showcasing innovative leadership. Congratulations to Captain Rajesh Uni, who has helped in transforming the maritime industry into a greener place. Captain Rajesh Uni is the founder and CEO of Synergy Marine Group. In a long and illustrious career, he is recognized as amongst the most influential personalities in the maritime industry globally. In 2006, he launched his own vessel ownership and management company. Now, with its diverse fleet totaling more than 400 vessels, Synergy is one of the world's leading ship managers. Let's hear a few words from Captain Rajesh Uni.
Good evening, ladies and gentlemen. It's an honor to be able to join you today. And hopefully, we'll all be doing this more regularly in person very soon. Thank you, GREEN4SEA and Safety4Sea, for this award, which generously recognizes the efforts of Synergy in tackling the challenges of decarbonization. Now, leadership, it's a word discussed around a lot, and it can be hard to pin down. Be a leader, not a follower, we are told. Leadership is a quality of our politicians and business leaders are lauded for having or accused of lacking. But in the context of climate change, I believe we all need to be leaders. And leadership rarely is not about telling others what to do. For Synergy, it's been about collaborating with our clients, our suppliers, and the wider industry. It's been about doing whatever we can to cut emissions, sharing data, developing new products, identifying best practices ashore and at sea. In fact, tackling climate change is not about leadership or followership at all. It's really about fellowship. Because if we don't work together as a global community or as a shipping community, we won't be able to save the planet for those that follow us. It's really as simple as that. So let's all work together, let's collaborate, let's decarbonize now, because it's really now or never. Once again, thank you for considering us for this award.
Thank you to everyone who joined us today from wherever you are around the world. Congratulations to all winners. Thank you for making the industry a better, greener and more sustainable place. Many thanks to our award sponsors Irma First and McGregor. We look forward to seeing you in our next round of awards. Stay tuned as the 2022 GREEN4SEA Virtual Forum is not over yet. Tomorrow, the event will focus on alternative fuel options, ESG and many more green topics, so don't miss it. Thank you for watching.